welcome to Vedantu Neet English. I'm Diksha Kaushal, your chemistry master teacher. And today we are going to do redox reactions and electrochemistry in one go. So are you all ready for the session? Everybody do write it in the comment section. Everybody in the comment section, are you all ready for the session? Yes, everyone, because because of such large screen time, I have to wear spectacles today. So now you will today see the Chashmish Diksha Kaushal ma'am. Yes, everyone in the comment section, are you all ready? Are you all ready? Green hearts in the chat box. Everyone, green hearts in the chat box so that we can start the session. Right, starting off with the redox reaction, then we are going to complete electrochemistry along with the previous year question. And students, for sure, they are going to ask you questions from electrochemistry, like 100% sure. And for electrochemistry, you need to know the basic of redox reactions as well. Yes, everyone, are you all ready? Ready? So everyone, green hearts in the chat box so that we can start the session with this beautiful smile on your face. And then we are going to jump into this lecture. Yes, I can't see green hearts. I can't see green hearts. I want to see those green hearts. Okay, green hearts. Yes, everyone, because this universe should be greeny, right? Evergreen chemistry. Sumati, oh my God, why is the energy so low? Why is the energy so low? What happened? Is this like, oh man, this is good afternoon. So in afternoon, we are very like low in energy. Is it so? No? Okay, perfect. Now let us start the session. There are a few basic things, okay, that we are going to cover. First is, what is a redox reaction? Okay, what is a redox reaction? Okay, in first 1.5 hour, I am going to complete redox reaction. Okay, after that we will have a break of 20 minutes. Okay, this is going to be our today's session. Okay, in first 1.5 to 2 hours, that means at around 3 p.m. or before 3 p.m. we are going to complete redox reactions. Right, after that we will have a break of 20 minutes. You have your lunch and all. After 20 minutes we are going to start electrochemistry. Okay, electrochemistry, that is also going to take around 2.5 hours. Okay, so that is the schedule for today. Yes, everyone? Okay, perfect. So now let us start with redox reactions. In redox reaction, bacha, in redox reactions, what is redox? Okay, this is R-E-D-O-X. This means that this is the reduction part, this is the reduction part, and this is the oxidation part. This is the oxidation part. So everyone in the comment section, if you talk about this is redox, now here are two things. Okay, when two things are occurring simultaneously, that is called a redox reaction. First thing is reduction, and the second part is oxidation. Okay, the second part here is oxidation. For reduction and oxidation, what we are going to do? For reduction and oxidation, what we are going to do? For reduction, students, for reduction, what we have here is, for reduction we say it means gain of electrons. In terms of electrons, it is called gain of electrons. For oxidation, it is loss of electrons. Okay, this is gain of electron, this is loss of electron. Okay, now in this chapter we are going to talk about gain and loss of electrons only. Okay, so in reduction, the oxidation number, everyone here, what happens here? The oxidation number decreases. I'll tell you what is oxidation number, and here oxidation number increases. Okay, and what about the very basic definition? The very basic definition is that in reduction, you have addition of hydrogen. or loss of oxygen, right? In oxidation, you have addition of oxygen and loss of hydrogen. Okay? Yes, this is the basic definition of reduction and oxidation. When there is simultaneously gain and loss of electron, that is called a redox reaction. Okay, that is called a redox reaction. Now let us get into the examples of this oxidation, which addition of oxygen and electronegative atom, removal of hydrogen or electropositive element, right? So what are the formulas here? The formulas are this one. Okay, so here what is happening? There is addition of oxygen. So this is the example of oxidation, right? Okay, and what about this one? Here the hydrogen is removed from HCl. So this is called the removal of hydrogen, that is reduction. In this negative electronegative element is added. Okay, so Cl negative is added to this one. That means here we are doing the reduction, here we are doing the oxidation part. Okay, oh wait, this is also oxidation, because here hydrogen is removed. Okay, hydrogen is removed from HCl, right? Then we have electropositive element is removed. Here electropositive element, that means this Na is removed. Okay, that means this is also the example of oxidation, right? Okay, next is the reduction part, where we have addition of hydrogen and loss of oxygen. Here we have loss of oxygen for Fe2O3. Then bacha, we have addition of electropositive. What are the electropositive elements? Like metals, that belongs to group number 1, group number 2. Those are the electropositive elements, right? So addition of electropositive elements. Then we have removal of electronegative element. Okay, this is the removal of electronegative element. That means FeCl3, here it will be removed to this one, and here you will have removal of electronegative element, right? So these are the basic definitions. In this chapter we are going to use this definition, that is oxidation is the loss of electrons and reduction is the gain of electrons. Okay, so for example, you have something like this, that is Sn2 positive to Sn4 positive. Okay, it should be Sn2 positive to Sn4 positive. It is Sn2 positive to Sn4 positive. This means that there is increase in the oxidation state. There is loss of electron. That means here we have oxidation, right? And in this part, what you are doing? In this part, you have O2, that is at zero oxidation state, to O2 negative. So the oxidation state is from 0 to -2. That means there is gain of electron. That is why it is gaining a negative charge, right? So that means it is decreasing. There is decrease in the, from 0 to -2, there is decrease in the oxidation state. That means this is the reduction part. Okay, this is the reduction part. Yes, bacha, what happened? Now, next is oxidation number and oxidation state. Okay, now let us talk about what is oxidation number and what is oxidation state. For that, let me clearly tell you one thing. For example, we are going to calculate the oxidation state. So what is the difference between oxidation state and oxidation number, right? For calculating that, firstly let us understand what is oxidation state. From oxidation state, we will understand what is oxidation number and what is the difference between oxidation state and oxidation number, and what are the conditions when oxidation state and oxidation number is same, right? Okay, so now beta, we have this thing, wait. Now we have this thing where we are going to calculate this part, that is, here we have H2, right? You have H2, you have water. So how you calculate the oxidation state? For example, this is the structure of water, right? Okay, so what is oxidation state? It is how many electrons are gained or lost. Okay, so if we say hydrogen, this is electropositive in comparison to oxygen. This is electropositive in comparison to oxygen. This is electronegative in comparison to hydrogen, right? So now what you saw, that this one hydrogen in this covalent bond, right? In this covalent bond of OH, this one hydrogen has 2 electrons in this, right? That means it is gaining, right? It is actually not, this is electropositive, that means it is giving, right? It is giving what? It is giving 1 electron to this OH bond, right? It is giving 1 electron, bacha, because here the electrons must be somewhat like this. Okay, why so? Why not exactly in the center? Because oxygen is electron negative. That is why the electrons are more towards the oxygen side, right? The electrons are more towards the oxygen side. So here we will say that is the reason we say it has +1 state, +1, because it is giving 1 electron, right? It is giving 1 electron, and here this hydrogen is also giving 1 electron. This is also +1, and this oxygen is gaining 2 electrons, okay, from this side. From which side? It is gaining 2 electrons from this side and from this side. So we can say it is having -2, okay, it is having -2, and that is how we say in this particular structure, water has, oxygen has oxidation state -2, hydrogen has oxidation state +1. This is the oxidation state. Yes, students, is this clear to you? This is the oxidation state here. Now let us understand this with the help of one more example, that is H2O2. That is H2O2. For H2O2, you have this hydrogen, you have this oxygen, you have this oxygen, you have this hydrogen. In this case, what you will say? See, here the oxidation state of hydrogen is going to differ. Okay, what is the reason behind that? So, see this. In this part, here it is electropositive, this is electronegative, this is electronegative, this is electropositive. So now, this hydrogen is giving electron to this oxygen, and this hydrogen is giving electron to this oxygen, right? Okay, this hydrogen is giving electron to this oxygen. So now what we have, bacha, what we have, this hydrogen is giving electron to this oxygen, this hydrogen is giving electron to this oxygen, right? Okay, so now let us understand this. Now 1 electron it will give off here to this oxygen, so it will have +1 oxidation state. This hydrogen is giving 1 electron to this oxygen because it is electropositive. It is going to give the electron. Electronegative is going to gain the electron. So it is also +1 oxidation state, right? What about this oxygen? So now, bacha, this oxygen, everyone here, this oxygen, it does not have, this oxygen does not have, here it is just gaining 1 electron from this side. There is no electronegativity difference between this oxygen and this oxygen, right? So that means it is not gaining anything from this oxygen, right? So that means it is gaining electron from just this oxygen. So we will write here the oxidation state is -1, and here also it is just gaining electron from this side. So it will be -1, and hence we say in hydrogen peroxide the oxygen has oxidation state -1. Yes, student? Next, student. So here oxygen has, here bacha, oxygen has -1 oxidation state and hydrogen has +1 oxidation state. Yes, students, is this clear to everyone? Why here oxygen has -1 and why here oxygen has -2 oxidation state? Yes, students, is this clear to you? Yes, okay. Now, next thing is that, next thing bacha that we are going to do here is, next thing is, what is the difference between oxidation number and oxidation state? What is the difference between oxidation number and oxidation state? Right? Okay. So, for example, you have something like this. Okay. You have something like this. Okay. This is H2 S3O5. Okay. Okay, so we have some structure like this. Okay, right? So now let us calculate the oxidation state of sulfur here. Okay, let us calculate the oxidation state of sulfur here. Right? Okay, so now let us understand this. This oxygen is going to have -2 oxidation state because it is gaining electron, right? This is gaining electron from this side, this is gaining electron from this side, so -2. Again this is -2, again this is -2, again this is -2. Right? Okay. So now see, you all know that along the period electronegativity increases, right? Down the group electronegativity decreases, right? So if you say out of oxygen and sulfur, oxygen is going to be more electronegative as compared to sulfur, right? Because down the group electronegativity decreases, so that means this is more electronegative. It is going to pick it. This is more electronegative as compared to hydrogen and as compared to sulfur, so this is going to have -2 charge. Oxygen has same charge all over and hydrogen has +1 charge all over, right? Hydrogen has +1 oxidation state all over. Now let us talk about this sulfur atom. Now let us talk about this sulfur atom. If you talk about this sulfur atom, what is this sulfur atom? This sulfur atom is going to have -1. Why? Because this sulfur atom is connected to two sulfurs here. It is connected to one sulfur and one hydrogen, right? For this sulfur, it is going to have -1 charge, and with this sulfur, see, if you have sulfur and sulfur, there is no electronegativity difference here, right? There is no electronegativity difference here, okay? Okay, there is no electronegativity difference between this sulfur and this sulfur. So what we are going to say, there is no electronegativity difference. That means it is not going to accept any electron from this sulfur because they belong to same family. Right? They're the same atoms. They're twins. So they're not going to take anything from each other. Right? It is only going to take electron from this hydrogen. Hence it will have -1 charge here. Okay? Hence it will have -1 oxidation state. What about this sulfur? Everyone, what about this sulfur? This sulfur is going to, this is in comparison to this oxygen and in comparison to this sulfur and this sulfur. This sulfur and this sulfur, it has no electronegativity difference. It has electronegativity difference with this sulfur, that is +2, and here also it will have +2. So total, if this is sulfur number 1, this is sulfur number 2, right? If this is sulfur number 1, if I say this one will have -1, and this is going to have +4, and this is going to have, and this sulfur is going to have, +2, +2 and +1. Okay, so this is going to have +5. This is going to have +5, right? So this is the difference in the oxidation state in one molecule of all the sulfur atoms. That means when we talk about this hydrogen peroxide, in this case the oxygen atom, both the oxygen atom has -1 oxidation state. So oxidation number is also going to be -1 only. But if we talk about this sulfur number 1, this sulfur number 2, this sulfur number 3, these three sulfur have different oxidation state. So oxidation state of sulfur is equals to, that is -1, +4 and +5. Okay, so oxidation number is going to be the average of all these oxidation states. Yes, students, so oxidation number is going to be the average of all these oxidation states. Yes, is this clear to you? Right? So that is the difference between oxidation state and oxidation number. Yes, students, explain the right side sulfur. This one sulfur, okay. So bacha, see this. This sulfur, okay. Let me erase it here. This sulfur is connected to two double bonds here. Two double bonds of oxygen. One single bond of oxygen. One single bond of sulfur. With sulfur and sulfur, there is going to be no electronegativity difference. So it is not going to accept any electron, right? So we can eliminate this sulfur. We can eliminate this sulfur because no electronegativity difference. Now it is connected with 3 oxygens, right? Okay, here it is connected with one single bond. So what we can say, here it is going to, this is more electropositive, it is going to give 1 electron here, that is, it is going to give plus 1 electron. It is going to give electron, that is plus 1 oxidation state. Here it is going to give 2 electrons, that means plus 2. Here also it is going to give 2 electrons, that is plus 2. So total it will have plus 5 oxidation state. Yes, students? Yes, students. Okay, I'll slow down. Don't worry, I'll slow down. Yes, students. Now is this clear to you? Now is this clear to you? Yes, students. Now is this clear to you? Okay. So now beta, we had this particular structure in which we had 3 sulfurs, right? So these 3 sulfurs have different oxidation states. This sulfur has -1 oxidation state because this is more electronegative as compared to hydrogen. This sulfur has +4 oxidation state because it is connected to 2 oxygen with a double bond. Here it will be +2, it will donate +2 electrons, so together it will form +4, right? And with this sulfur, it is connected to 2 double bonds here, 2 double bonds here, 1 single bond here. That means 1 electron to this sigma bond, 2 electrons to this double bond, 2 electrons to this double bond. Together it will have +5 charge. Yes? Okay? Yes, students? So this is going to be the different oxidation states for all the sulfur atoms here, right? For that we take the average of all the oxidation states and that is called the oxidation number. Now let us discuss the rule of oxidation number for different compounds. Now let us discuss this, students. First thing that you have is oxidation number of any uncombined element that is in the free state, that is going to be 0. Okay, that is sodium, anything that is in its free elementary state, that is going to be 0. No oxidation number, no oxidation state. Oxidation number of monatomic ion. Mono, see, when you have same oxidation number states for all these, okay, here oxidation number is equals to oxidation state. Why? Because here all the oxygen has same oxidation state, so oxidation number is same as oxidation state. Okay, so in general when we talk about simpler compounds, when there is no differentiation of oxidation states, in that case we say simply we write oxidation number. Okay, in place of oxidation state we write oxidation number, right? Next, bacha, students, we have more electronegative element is in a binary compound is assigned the number equal to the charge it would have if it were an ion. For example, you have NO, right? Now you have the oxidation state of oxygen in NO is going to be -2. Why? Because if oxygen is in the ionic state, it would have -2 charge on it. That is the charge is equal to the oxidation number. The oxidation number of fluorine in compound is always -1. Students, I am going to write few oxidation numbers here, right? For example, for group 1, that is going to be +1. For group 2 elements, that is going to be +2. For group 15 elements, that is going to be -3. For group 16 element, that is going to be -2. And for group 17 element, that is going to be -1. So these are the oxidation states that you usually see in your exams. Okay, these are the oxidation states that you usually see. Next, students, we have hydrogen oxidation state. In most of its compound is +1 because it belongs to +1, it belongs to group number 1, but somehow in some compounds it is also -1. For example, if it is connected to, if it is combined with a metal, okay, that is more electropositive. That is, for example, you have NaH, right? For example, you have NaH. In that case, this will be +1, this will be -1. right? If it is connected to a metal, electropositive thing, in that case hydrogen is more electronegative. If there is something positive, then hydrogen will be negative. Otherwise, as compared to non-metals, this is always going to be +1 oxidation number, right? Now, next thing is, in compound, the elements of group 1 and 2 as well as aluminium have oxidation number +1, +2, +3 respectively, right? So, what they are talking about, that group 1 and group 2 and group 13 can have the oxidation number +1, +2 and plus all these oxidation numbers, right? Next is the sum of oxidation number of all the atom in a neutral atom is 0. Now we will see this. The sum of oxidation number of all the atom in a polyatomic equal to charge on this. See, we are going to CaCO3 and H2. Let us discuss this. CaCO3, right? So, the oxidation number of all the elements is going to be 0. How? The calcium, this belongs to the second group. So, this is going to be +2. The carbon, for example, let us take X here. So, this is going to be -6 is equals to 0. Right? The oxidation states of all the addition of oxidation state of all the atoms is going to be 0. That is going to be X is equals to 4. So, carbon will have the oxidation state 4. Right? So, this is how we talk about this one. Right? And then, if I say oxidation number of H2PO4 negative. In H2PO4 negative, right? Now, as this is a charged species, if it is a neutral species, that is going to be 0. If it is a charged species, that is going to be -1, the charge on the molecule, right? So it is going to be 2 into +1, because hydrogen is connected to a non-metal, right? So plus X. X is for phosphorus, -8, that means 2 into 4, that means you can see +4 into -2, because oxygen has -2, equals to -1. So this is going to be X is equals to 6 minus 2, X is equals to +4, right? So this is how, this is a very useful thing in all your organic, in all your inorganic chemistry. You are going to get so many questions based on this in coordination chemistry, and so many questions based on this, how to calculate the oxidation number, right? How to calculate the oxidation number. There are so many practice questions based on this, right, students? So why this is 5, 4, 2, 8, oh, this is -1, no, so this is going to be 6 minus 2 minus 1, this is going to be wait, should be -2. What I did wrong? 2 plus x minus 8. Okay, 2 plus x minus 8. This is -1. So x is going to be 8 minus 2 minus 1. That is going to be 5. Right? So answer is going to be 5 here. Yeah? No. I did calculation mistake here. Okay? I just multiplied 3 with 2. This would be 8. Okay? So now this is the correct answer. So next thing is, students, consider the elements. Now this is your NCERT question. Consider the elements CS, Ne, I, F. Identify the elements that exhibit only positive oxidation state. So which will exhibit only positive oxidation state? The metals are going to exhibit only positive oxidation states, right? Identify the element that exhibit both positive and negative oxidation states. Now students, which exhibit both positive and negative oxidation states. See this? Now cesium, which is only having only positive oxidation state because it belongs to group number 1, right? Out of these, this is the noble gas, this belongs to halogen family, right? This would be -1. So this is the only one that is a metal that belongs to the group number 1. So this is going to possess +1 oxidation state. Next is iodine, shows both negative and positive oxidation states, right? You will see that iodine, if you say this is it forms -1 oxidation state and positive states like +3, +5 and +5. For example, I have IO3 negative. Now here oxidation state is going to be X minus 6 equals to minus 1, that is going to be plus 5. Right? So here oxidation state is plus 5. So iodine, because it is a halogen, it possesses minus 1 oxidation state in I negative, and it can also possess other oxidation states like plus 3, plus 5, plus 7. For example, if we talk about IO3 negative, it is going to possess plus 5 oxidation state. So this possesses both positive and negative oxidation states. Yes, students? Okay. Now clear? Yes? Now let us see this. Let us see this. Now student, what is the fractional oxidation number? So some elements have oxidation number in fractions. For example, let us see this, how they are in fractions. Let us see this. First is C3O2. Okay. Now see this very carefully. I am going to show you this diagrammatically. Right. So you have C3O2. How this is showing fractional oxidation number. Right. So you know this carbon is actually, this carbon, if you draw this, wait, let me draw this. Okay, so if you draw this, now let us see how it is going to show this. Okay, see, this carbon is connected to two other carbon atoms only. There is no electronegativity difference. If there is no electronegativity difference, it is not going to pull the electrons or give the electrons. Both are on the same electronegativity. So the oxidation state or oxidation number is going to be 0. Right? That is going to be 0. Now, let us talk about this oxidation number. Now, let us talk about the oxidation state of this particular carbon atom. Right? So, for this particular carbon atom, it is having no electronegativity difference with this carbon, but it is having electronegativity difference with this oxygen. That means this is having minus, this is actually giving, this is oxygen is more electronegativity negative than carbon. So carbon is going to have positive oxidation state in comparison to oxygen. So this is going to give 2 electrons to this oxygen because it has 2 double bonds. Okay, it is going to give 2 electrons to this oxygen, and hence this is going to have +2 oxidation state. Right? Similarly, this carbon is going to have, it is going to have no electronegativity difference with this carbon, but this is going to give 2 electrons to this oxygen atom, 1 electron here, 1 electron here. Right? So total it will have +2 oxidation state. Right? Now next is this oxygen is going to pull the electrons, 2 electrons, because it has 2 bonds, right? So the oxidation state is going to be -2. This oxygen is also going to pull 2 electrons from the carbon, so this is going to be -2. Right? So now what is the oxidation number? What is the oxidation number? As I told you, that will be the average. So average means you have 3 carbon atoms, right? Oxygen has same oxidation state, right? -2, -2. Carbon has different oxidation state, that is +2, 0 and +2. So we can write divided by 3 because we have 3 atoms here. This is +2, this is +0, this is +2. So it is going to be 4 by 3. So oxidation number on a single carbon atom is going to be 4 by 3. Yes, students. So oxidation number on a single carbon atom is going to be +4 by 3. Right? Oxidation states are different. Oxidation number is different here. Yes, students. Yes, everyone. Now let us discuss the next example, that is Br2O8. Okay, for Br2O8, bacha, what we have now, let us discuss the average oxidation number here. Okay, let us discuss the average oxidation number here. Br3, right? Br3 oxygen 8. 1, 2, 3. 4, 5, 6, right, 7, 8, right? Okay, yes. Now let us discuss this structure. See how you're going to see this. Now students, everyone here, I want all of you to answer this, okay? If you don't do this yourself, then it will be very difficult for you, right? Try to do it yourself along with me, right? Now let us see this bromine, right? This bromine is going to have, there is no electronegative difference with this bromine. So no, it is not going to pull electron from this side. It is going to pull 2 electrons from this side, going to give 2 electrons to this side, okay? Which is more electronegative? Bromine is more electronegative, is it? Yeah. Yes. Okay. Wait. So you have, this is fluorine, this is bromine. This is decrease in electronegativity, and here oxygen will have more electronegativity as compared to bromine, right? If it would have been fluorine, in that case this would have been, if this is fluorine, if you have fluorine and oxygen, in that case oxygen is going to be less electronegativity as compared to fluorine. But if you are talking about bromine and oxygen, this is going to be more electronegativity as compared to this bromine, okay, as compared to this bromine. Now students, what we are going to have next is, this is your bromine. This is going to have 2 electrons, okay, this is going to have 2 electrons, so it is going to add 2 electrons, that is +2, right? This is going to give 2 electrons, that is +2 here, and it is going to give 2 electrons to this one, that is +2 here, right? Also +2 here, +2 here, and +2 in this case. Okay, so you have +2, +2, +2 on this bromine atom, right? In this case, bromine will have what? Bromine will have +2 in this case. Bromine will have +2 in this case. So total bromine, here bromine has +4 oxidation state. Here bromine has +6 oxidation state. Here bromine has +6 oxidation state, right? So in total, what you will say, oxygen is going to have -2 as it is always connected to double bond, right? So we will say oxidation number is going to be, that is +6 + 4 + 6 divided by 3, that is 16 by 3 is going to be your correct answer for oxidation number on each atom, right? On each bromine atom. Very good afternoon, bacha. Very good afternoon. Okay, right? Understood this? Now if you talk about this one, okay, we have done this. If we talk about this one, that is wait, let me draw this here. 1, 2, 3, 4. This was double bond here, double bond here, double bond here, double bond here. Now bacha, this is going to be our last question where we are going to discuss fractional of this. Right? I want all of you to answer this. Okay? I'm writing it here. I'm mentioning the sulfur number 1. This is sulfur number 2. This is sulfur number 3. This is sulfur number 4. Now everyone, do let me know what is going to be the oxidation state on all the sulfur atoms here. What is going to be the oxidation state of all the sulfur atoms here, and what is going to be the oxidation number, that is average of oxidation state. Right, that is average of oxidation states. So guys, what we have here is sulfur number 1. Okay, sulfur number 1, that is having electronegative difference only with this oxygen, and this oxygen. Right? So what it is doing, it is going to give 1 electron, 2 electron to this one. It is going to give 1 electron to this one, and it is going to give 2 electrons to this one. Right? 1 electron here, 2 electron here, and 2 electron here. Here it is having 0 and it will be 0. Right? Okay. Yes. Now here sulfur number 1 and sulfur number 4 is going to have plus 5 oxidation state. Sulfur number 2 and sulfur number 3 is going to have 0 oxidation state, and total oxidation number is going to be, that is sulfur number 1 plus sulfur number 2 plus sulfur number 3 plus sulfur number 4 divided by 4, right? Okay students, so now that is going to be, everyone here, that is going to be plus 5 plus 0 plus 0 plus 5 divided by 4, that is 10 by 4. Okay, so here the fractional oxidation number is going to be 10 by 4. Yes students, that is going to be 10 by 4. Yes students, that is going to be 10 by 4. Okay students, yes, that is, yes, exactly, that is going to be plus 5 by 2, right? So that is going to be plus 5 by 2. Plus 5 by 2 is going to be the right answer. Okay, any problem here? Any problem here? Any problem? Any problem students? Okay, now we have discussed that. Next part is, see, another part. I thought this is the last question. How many other? We have two very important structures based on this, two very important structure. This is the first one, that is H2SO5. So here, bacha, students, everyone, what is going to be the correct answer? I think this is H2SO5. See this. Okay, how we defined it? How we defined it, students? See. Now, I think that is a game of 10 seconds for you now, right? That is a game of 10 seconds for you now. You have sulfur is more electronegative as compared to sulfur and hydrogen. It will have -2. This is going to have -2. This is going to have -2. Again, this oxygen is going to have, -1 here, because there is no electronegative difference here. This oxygen is also going to have -1 here. Okay, this oxygen is also going to have -1 here, and this sulfur is going to have +2 here, +1 here, +2 here, +1 here. This sulfur is going to have +6 oxidation state. Oxygen will have oxidation number equals to -2 here, -2 here, +1, -1 here, -1 here, and -2 on this side. 1, 2, 3, 4, 5. Total you have 5, and that is going to be 1, 2, 3, 4, 5, 6, -6 by 5. Okay, so all the oxygen atoms together are going to have -6 by 5. Okay, yes students, together they are going to have -6 by 5. Oxidation state, this is the oxidation number, and sulfur will have +6 because there is only one sulfur which has oxidation state or oxidation number that is equals to +6, right? Okay, okay students. Now next is the butterfly structure, very very important, that is asked in your PYQs, very important, right? Very important structure, Cr2O5. So this is actually, this exists. What students do, they do this x minus 10 is equals to 0, that x is equals to +10. No, this cannot be +10. Chromium does not have +10 oxidation state, right? It is not possible, right? So what is the oxidation state here? It has actually a butterfly structure. Okay, what is this butterfly structure? This is the butterfly structure that this has. Okay, this is the butterfly structure that it has. That is Cr2O5 has butterfly structure. So here what you see, this is the chromium. Okay, so chromium is going to get 2 electrons. It is going to give 2 electrons to this oxygen, that is +2. It is going to give 1 electron to this oxygen, that is +1. 1 electron to this oxygen, 1 electron to this oxygen, and 1 electron to this oxygen. Together it will have, chromium will have +2 +1 +1, that is 1, 2, 3, 4, that is +4, that is going to be, chromium will have 6 oxidation state. Okay, 2, 3, 4, 5, 6. Okay, it is going to have plus 6 oxidation state here. Yes, bachcho, it is going to have plus 6 oxidation state here, not plus 10 oxidation state. This is actually a butterfly structure. Butterfly structure. Okay, this exists as a butterfly structure. Right? Okay. Next, students, we have what is the change in oxidation number of carbon in the following reaction. Now tell me, what is the change in the oxidation number of carbon in the following reaction? So carbon with hydrogen, this is having carbon with hydrogen is having plus 4 oxidation state, right? This hydrogen is actually plus 1, so this carbon will be minus 4. So this is going to be minus 4 oxidation state here, and this halogen is negative, electronegative. So carbon is less electronegative as compared to chlorine, and it is more electronegative as compared to hydrogen. So here it will have minus 4 and here it will have plus 4 oxidation state. So it is going to shift from minus 4 to plus 4 oxidation state. Very good. C is going to be the correct answer. That is asked in your 2020, right? NEET 2020, the question has been asked. That is very simple, minus 4 to plus 4. Very simple question. Okay. Next part that we have is oxidation state of CrO5 is. Now students, what is the oxidation state of, that is asked in 2019, 2014. This having a butterfly structure. What was the oxidation state here, students? What was the oxidation state here? Oxidation state was plus 6. Okay, oxidation state, we have just drawn the structure, that was this. Okay, the structure was this, right? This was the structure that we have just drawn. Right, students? Okay. Yes, everyone. Okay, shall we, any problem in calculating the oxidation number? Any problem in calculating the oxidation state? Any problem in calculating the oxidation number or calculating the oxidation state? Yes, perfect, perfect. Now students, next we are going to have this oxidizing and reducing agents. So see, always remember this, like I am a teacher, I teach you, right? That is why I said she is teaching, because I teach you, right? What the work I do, I am regarded as that thing, right? I am a teacher, I teach you. Then in the same way, the atom or the element that oxidizes someone is the oxidizing agent. I am not teaching myself, I am teaching you. That is why I am a teacher, right? Okay, so something that oxidizes some other thing is called oxidizing agent, which itself get reduced, right? Which itself get reduced is the oxidizing agent. Okay, for example, I want to get reduced, right? That means I will oxidize you, then I am oxidizing agent. If I want to get oxidized, that means I want to reduce you, only then I will be oxidized, right? So I am a reducing agent, right? Okay, yes. So oxidizing agent oxidizes other substance, itself get reduced, electron acceptor. Reducing agent which reduces other substance and itself gets oxidizes, that is electron donor, right? Okay, so this is the example here. So everyone, oxidizing agent, reagent which increases the oxidation number of this is very simple. Okay, you don't need to get into the definitions here. Okay, so now see this very simply. Like here you have sulfur is from -2 to +4. See this. Sulfur here is, see this. Sulfur here is getting converted to, see this. Sulfur here is getting converted to which part? Everyone here. Sulfur here is getting converted to -2 to +4. That means the oxidation number is increasing here. That means this is the oxidation. That means here the oxidation is happening. That means this particular compound is getting oxidized, it means it is a good reducing agent. So what you will write, Cu2s is a good reducing agent. It is a good reducing agent. Okay, it is a good reducing agent, right? Okay, next part is here you have oxygen, you have this copper that is having +1 oxidation state and it is getting oxidized again. Oh, this is decreasing, yeah. Okay, so here this is come from +1 to 0 oxidation state. That means the oxidation number here is decreasing. So that means that Cu2O is oxidizing agent. Okay, this is the oxidizing agent. Why? Because here reduction is happening. When something is getting reduced, it is a good oxidizing agent. Okay? Yes? Okay. Now students, let us jump to the questions here based on this one. That is NEET 2016 question that you have. Hot concentrated sulfuric acid is moderately strong oxidizing agent. What we are saying? Hot concentrated sulfuric acid, everyone. Hot concentrated sulfuric acid is moderately strong oxidizing agent. Which of the following reaction does not show oxidizing behavior? Okay. Is moderately strong oxidizing agent, which of the following reaction does not show oxidizing behavior? This is, let's just see the conversion. Okay, this is from 0 to +2. So this is the oxidation state is increasing. This is showing the oxidizing behavior. Right, here the sulfur is going from 0 and here it is x minus 4 is equals to +4. Right, so here also it is increasing, so this is also showing oxidizing behavior. See, we have also studied that in P block that H2SO4 is a very good oxidizing agent. It's a very good dehydrating agent, right? So here carbon is having 0 oxidation state and here it is having x minus 4 is equals to 0, that is +4 oxidation state. Also here it is increasing. Here calcium is having +2 oxidation state and here it is having +2 oxidation state. That means there is no change in that, right? So here it is not behaving as an oxidizing agent. H2SO4 is not behaving as an oxidizing agent. So D is going to be the correct answer because they are asking you does not show oxidizing behavior. That is D is going to be the correct answer. Very good. Okay. Yes. Next students, we have some kind of reactions here. Okay, some kind of reactions. First part is either A and B or both A and B must be in the elementary form such as a reaction to be redox reaction. So what is combination reaction? That is when you have two compounds or elements are combining with each other to form a single compound. Okay. A and B are reacting with each other to form a single compound, that is called the combination reaction. Okay, that is called the combination reaction. Here students you have, I don't know what is happening to this mic. What is happening to you, bro? Why you are not giving help to us, any use of us now? Okay, so now students we have carbon and oxygen that is getting converted to carbon dioxide. Okay, so that is the combination reaction. Okay, that is the combination reaction. Next is decomposition reaction, when a single reactant is getting decomposed into two or more products. A single reactant is decomposing into 2 or more products is called decomposition reaction. Okay, then displacement reaction is when something is getting displaced. Okay, so here X is actually very we will study that in electrochemistry, right, today itself, that if X has more reducing power, right, that is stronger than hydrogen or any other element, it is going to replace this, it is going to replace Y here and it is going to form a compound X and Z, and Y will be very sad here. Why Y will be sad? Because now the bond has been broken by X here. X has replaced Y in this YZ compound. that means that here we can see that here something is like very strong. If X is not strong as compared to Y, then this will not happen. Okay, and what about that strong or weak? That we'll study in the reactivity series. Okay, that we are going to study in the reactivity series. Next is the displacement reaction. We have two type of, that is metal displacement and non-metal displacement. Metal displacement is that you have this metal, okay, this metal will displace this metal, that is the metal displacement. Here this hydrogen is not the metal, okay, this is the non-metal displacement, okay. So this metal is going to displace this oxygen, right, that is going to be the non-metal displacement, okay, that is going to be the non-metal. Here metal is displacing metal, and here we have, this is Na, right, this metal is going to get added to this OH, okay, right, so that is not displacing any metal, that is displacing a hydrogen here, so that is going to be a non-metal displacement, right, okay. Next is disproportionation reaction. Disproportionation reaction means to break into something. In a reaction, the same element exists in three different oxidation states. It is called disproportionation reaction. Three different oxidation states, okay. So you have phosphorus 0, phosphorus minus 3, this means that an element that was earlier in one oxidation state, after the reaction, it is going to get oxidized and reduced. Here 0 is converted to -3, that means reduction, and it is also converted to +1, that means oxidation. So disproportionation reaction is that when you have one element that is getting reacted and getting converted to an oxidation state which is more, an oxidation state which is less. So it is getting converted to both the things, right? So here we are going to write this P, this is going to get converted to -3 and to +1. That is the oxidation here. Yes, students? Okay, perfect. Next is the comproportionation reaction. So what is comproportion? That is the opposite of this, right? Class of redox reaction which element from two different oxidation states get converted into a single oxidation state. That is the opposite. Like decomposition is the opposite of combination. Same way disproportionation reaction has opposite, that is comproportionation reaction, which means you earlier you had in the reactant form you will have two oxidation state, that is you have two oxidation state. Now it is get converted to only single oxidation state. Disproportionation reaction is that when reactant side is having one oxidation state, product side is having two oxidation state, one more and one less, right? Comproportionation reaction is that when reactant side has two states and product side has just single state, right? Okay, yes, very good. Next students, let us see this question, Neet 2019 question, okay. Which of the following is the disproportionation reaction? Okay students, which of the following is the disproportionation reaction? You have Cu2 positive, that is getting disproportionation means it should be getting converted to two oxidation state. This is x minus 8 is equals to -1. Okay, this is x is equals to +7. Okay, this is x is equals to +7. This is x minus 4. This is +4, right? And this is x minus 8 is equals to -2. That is +6. So B is definitely disproportionation reaction, right? Here you have KMNO4, that means x minus 8 is equals to -1, that is +7. Oh yeah, that is +7, right? And here you have +7 is getting converted to x minus 8 equals to -2 equals to -2, that is x is equals to +6, right? And this is going to be x minus 4, that is +4. Okay, so you have +6, that is decreasing only. Here it is 1 increase, 1 decrease, right? And here you have MnO4 2, and this getting converted, this is definitely not, right? This is copper, that is increasing, and 1 is decreasing, right? So first and second, okay, first and second are the answer, right? Why not this one? Why not this one? See, here you have, this is In the first case, plus 1 is getting converted into plus 2 and 0. That means 1 is increased, 1 oxidation state is increased, 1 oxidation state is decreased, right? And here plus 6 is getting converted to plus 7 and plus 4. 1 is increased, 1 is decreased. Again, it is a disproportionation reaction. But in third one, you have plus 7 is getting converted to plus 6 and plus 4. Both are getting decreased. So both are getting decreased. That means that this is not a disproportionation reaction. The disproportionation reaction is that in the reactant side you have one oxidation state, one should be oxidized, one should be reduced. That is the disproportionation reaction. Okay, so B is going to be the correct answer here. Next, students, is before the balancing, let us talk about what is N factor. Okay, let us talk about what is N factor. Any student, what do you mean by N factor? Any idea on that? Any idea on what do you mean by N factor? Any idea what do you mean by N factor? Yes, students? Yes, students, any idea? What do you mean by N factor? After that, we are going to complete our redox reactions, okay? After the balancing N factor, we are going to complete the redox reaction. Then we are going to jump into electrochemistry, which is going to give you so many marks. I'm telling you that 3 to 4 questions will be asked from electrochemistry. Number of electron exchange, very good. N factor means size. No. Rajay Vasan, you are right. Number of electron exchanged, right? Okay, so now let us see what do you mean by N factor, right? What do you mean by N factor? So definitely it is true, that is the number of electron exchanged, right? That is the number of electron exchanged, right? So guys, if you want to calculate the number of electrons, okay, if you want to calculate the number of electrons, okay, exchanged, so how you are going to calculate that, everyone? For example, you have KMNO4, 2MNO2. Now tell me what is the N factor for this? What is going to be the N factor here? Right? What is going to be the N factor here? Here you have MnO4 negative, right? Okay, this is MnO4 negative, this is Mn2 positive, right? Here it is going to be this is going to be MnO2, right? Okay, so this is going to be x minus 8 is equals to minus 1, that is x is equals to plus 7. Here is going to be x minus 4 is equals to 0, that is x is equals to plus 4, right? So that is plus 7 and plus 4. So now everyone, so what do you mean by this? That means the N factor is going to be, the N factor here is going to be, everyone here, the N factor is going to be, the N factor is going to be number of electron, that is 7 minus 4, that is 3. Okay, 3 is the number of electrons that are lost here, okay, right? Okay, that are gained here, right? 3 electrons gained, right? There is reduction here. 3 electrons gained, the N factor is going to be 3 here. For example, you have something like this, that is N factor of, you can say MnO4 negative 2Mn. What is the N factor here, everyone? What is the N factor here? The N factor is very simple. That is, this is plus 7 and this is 0. So N factor is going to be plus 7 here, right? N factor is going to be plus 7 here. Right, students? So this is the second part. Or you can say, if you want to convert, you have next part, that is, what else? You can write here MnO2 2Mn positive, 2Mn, right? So what is going to be the n factor here? This is going to be x, this is going to be plus 4, and this is going to be 0. So n factor is going to be plus 4. Right? So these are the number of electrons exchanged. Now, second part is to calculate the n factor, of elements. Like if something is in its 2-3 things I will tell you. See, if something is it's in elementary state, right? For example, that I also told you in the some basic concepts of chemistry, that if something is like we are talking about Al3 positive, here n factor is going to be 3. If I am talking about Mg2 positive, here n factor is going to be 2, right? So when we talk about cations or anions, the n factor is going to be the charge on that atom. Okay, when we talk about the cations or the anions, bacha 11th class, 12th class and Neet, right? Okay, so if we talk about the electrons here, okay, the electrons here, 3 electrons will be gained, 2 electrons will be gained, right? Okay, now fifth part is if we talk about the acids or bases. Okay, if I talk about acids, everyone, if I talk about acids, so firstly let's talk about salt. Okay, let us talk about salt. So if I talk about a salt, that is MgCl2. So what is the n factor here? What is the n factor? After salts we are going to discuss with acids, bases, and then if you have a reaction that you have to balance, how to calculate the n factor for that reaction. Okay, so now, okay, done bacha. Okay bacha, K2Cr2O7 beta, K2Cr2O7, this is going to be, wait, I'm going to write it here only because K2Cr2O7, that is going to be plus 2x minus 14 is equals to 0, that is 2x minus 12 is equals to 0, x is equals to 12 by 2, x is equals to plus 6, right? So it is going to be plus 6, right? Okay, so that is going to be plus 6. That is not the n factor. This is not the n factor, this is the oxidation state. Okay, yes. So n factor you have to define that where you are converting this into. If I am saying that I am converting this into Cr, right, that will be n factor is going to be 6, right, because I am converted this into 0 state, plus 6 to 0 state, n factor is going to be 6 here, right? Okay, now if we talk about the salt here, salt is very simple. Okay, salt is very simple. How are you going to do it? Because Mg has 2 positive charge and Cl has 2 which has 2 negative charge, right? So that is n factor is going to be the charge on the ions, that is 2. Okay, that is going to be 2. N factor is going to be 2 here because positive charge is also plus 2, negative charge is also minus 2. So it is going to be the n factor is going to be 2 here, right? That is for the salt. Now next thing that we have is for, let us say we have it for let us assume that, okay, let us say for acids. Okay, for acids, for example, I have an acid that is H2SO4, right? For H2SO4 students, what we have for H2SO4, we have, what is the basicity? What is basicity, everyone? Basicity is not how much H positive ion an acid has. Okay, usually students get confused that basicity means how many H positive ion an acid has. No, basicity means that how many OH negative ions are needed. Okay, what is basicity, students? What is basicity? Basicity is how many OH negative ions are, needed to neutralize H positive ions. Okay, how many OH negative ions are needed to neutralize H positive ions, right? So in this case, that is called the basicity. That is called the basicity. That is called the basicity. So here what we say? Here we say how many ions are needed? We say 2 H positive ions are, two OH negative ions are needed, right? R for 2 H positive. So N factor is going to be 2 here, right? So N factor is going to be 2 here. That is the first case. Okay. Now, second thing. Okay. Second, no, that is not the number of ionizable H positive, Khushi. That is the number of OH negative needed to neutralize the H positive ions, right? That is the basicity. Now, if they tell you, now students, if they tell you something like this, if they tell you that you have 1 mole of H2SO4, or you can say the reaction is H2SO4 plus, the reaction says plus NaOH. Okay, this is the neutralization reaction. This is the neutralization reaction. Right, this is the neutralization reaction. Right? Okay, let us assume that this is the neutralization reaction. If they tell you that you have 1 mole, here you will say 1 and this is also 1. You will say 1 mole of H2SO4 need 1 mole of OH negative. Right? That means the N factor is going to be 1 here. So how much OH negative is needed for this 1 mole? Okay, here also to neutralize this, to neutralize 1 mole of acid. Okay, here the 1 mole. If you are not given, see this very carefully. If you are not, okay, bacha, see this very carefully. If you are not given, any H positive, like you are not given any reaction here, in that simpler way what you will write, how many H positive, that is it has 2 H positive, so it needs 2 OH negative, right? Okay, but if you have, students, if you have a reaction that is given to you, in that reaction 1 mole of H2SO4, 1 mole of OH negative, right? Because here we are not going into the how many H2SO4 in one this, we are just talking about 1 mole. Right? Here we are not provided with any reaction. Then we said this has 2 H positive. This requires 2 OH negative. But if you are given the reaction and this says 1 mole of H2SO4 requires 1 mole of OH negative. Okay, that is given in the reaction. Okay, for example, they give in the reaction that you have, they give in the statement that 1 mole of H2SO4 require 1 mole of NaOH, right? That means 1 mole of H2SO require 1 mole of OH negative. N factor is 1, right, students? Okay, yes. Now let us see the next part. That is, this one. The next part here is this one, where students you have, if they have given you, so try to answer this. If they have given you 2 mole of H2SO4 requires 1 mole of NaOH. Okay, if they give you something like this, now what is going to be your answer? If they ask you that 1 mole of H2SO4 requires 1 mole of NaOH, 2 moles, okay, so 2 moles of H2SO4 requires 1 OH negative, right, and 1 mole H2SO4 will require half OH negative, so N factor is going to be half here. Okay, if they do not mention any statement here, that means N factor is simply for H2SO4 it will be 2 only, because they have not mentioned anything. If they mention something like this, then in that case that is going to be half. Okay, yes students? Okay. Okay. Now students, everyone here. Yes, is this clear? Now shall I ask you one question? Will you try to answer that? Will you try to answer that? Okay. I'll give you one question, try to answer that, okay? Now, if I ask you that you have 1 mole of H2SO4 requires 2 moles of NaOH for neutralization, right? What is the N factor here? What is the N factor here? What is the N factor here, everyone? If I say 1 mole of H2SO4 requires 2 mole of NaOH, right? What is the N factor in that case? Very good, because 1 mole requires 2 moles of NaOH, that means 2 OH negative. So N factor is going to be 2 here, okay? Now, let us discuss about the last one, that is, let us discuss the basicity here, okay? Let us discuss the basicity here, right? Let us discuss for bases here, that means the acidity, right? So what is acidity, everyone? What is acidity? Number of H positive ions required for neutralization of 1 mole of base, okay? So here, if I say that you have, if we talk about CaOH twice, okay, generally what you will say, the N factor is going to be 2 here, okay? If I say students, NaOH, what is the basicity if you're not given, if it is the acidity, if you're not given any statement here, just this one, okay? In that case, simply we write N factor is equals to 1 because it requires 1 H positive, it has only 1 OH negative, right? But if in the statement they mention something like this, okay, what something they will mention? If in the statement they mention something like this, that you have students, everyone, what you have, they say 2 mole of NaOH require 3 mole H2SO4. See this, what is going to be the answer? 2 mole of NaOH require 3 mole HCl, right? So everyone here, what is going to be the answer here? What is going to be the answer? Beta, conformers come under the geometrical isomerism, right? You will see that in the chapter some basic concepts of organic chemistry. So you will see that there is a portion that is given to you. That is not given in some basic concept, that is given in hydrocarbons. Okay, you will see under hydrocarbons in your Neet syllabus they will mention that conformers of ethane and all, right? But you have to do the conformers of butane and cyclohexane also, right? Okay, so now this means that 2 mole NaOH require 6 H positive here, right? See this, 2 moles NaOH requires 6 H positive because 3 mole have 2 H positive, right? So 1 mole NaOH will have 6 by 2H positive, that is 3H positive. 3H positive, that is N factor is going to be 3 here. Right? Okay, so N factor is going to be 3 here. Next is 2 mole NaOH requires 3 mole H positive, that means 3H positive. This means 3H positive. So here we are going to write 1 mole NaOH requires 3 by 2H positive, that is 1.5. That is 1.5. Okay, just write it 3 by 2. N factor is equals to 3 by 2. Yes, students? Okay. Very good, very good, very good. Okay, perfect, perfect. Now let us do the N factor for next step, that is when you have a proper reaction. So I'll tell you in the proper reaction, that is this one. Okay, let us do the N factor for this reaction. Firstly, let us do the N factor for Mg plus. Okay. See, if in a reaction you have to find out, see, if I was finding the N factor simply like Mg is getting converted to MgNO3 twice, right? In that case, I just have to find the oxidation state of magnesium ion, right? That's it. Okay, that means this is +2, this is 0, and the N factor is going to be 2. Right, N factor is going to be 2 here. But if you have to find the oxidation N factor in a reaction, how do you convert it? Okay, if you have to find the N factor in a reaction, how do you do that? Okay, so I am going to do that for you here. How do you find the N factor? That is very useful in your balancing of chemical equation, right? So see this, how you're going to do this. Firstly, see the oxidation part here. See the oxidation part, everyone. What is the oxidation part? See the oxidation part. See the oxidation part. Okay, and this will be your reduction part. And this will be your reduction part. Right? So you have two parts here, oxidation part, reduction part. This is the oxidation where 0 is getting converted to +2. Right? So how to find the N factor of oxidation part? Write it as NO. And this is the N factor of reduction part, that is NR. Okay, so how do you find it? Just see the number, see this very carefully. See the number of magnesium ions on the left side, that is 1. Okay, number of magnesium ion on the left side is 1. So this is 1. Okay, this is 1 into, this is the oxidation state. Just take the mod of the oxidation state here. Mod of the difference of oxidation state, that is 0 to +2, 0 to +2, so that is going to be 2. Okay, so oxidation state, the N factor in the oxidation state is going to be +2. Right? Now let us talk about the reduction. Understood how we calculated for oxidation? This is 0 to +2, so 0 to +2, 0 minus 2, and this is 1, that is number of atoms here. Right? Okay, so for nitrogen you have 1 atom here, right? For nitrogen you have this is the reduction part, you have 1 atom here. This is the mod of oxidation state of nitrogen here and here. Okay, so that is going to be +5 to +1, right? So that is +5 minus +1, that is 4. Right? You calculated the N factor for the reaction in oxidation and in the reduction. That is NO and NR. Right? You have calculated this. After this, bacha, what we are going to do? What we are going to do? Oh my God. Okay, students. Now what we are going to do next? What we are going to do next? Now what we are going to do next is, oh my God, what just happened here? Oh God. Yes, I think this is good. Yeah. Okay. So now multiply the NO with the oxidation. This is the oxidation. Multiply the NR with the oxidation part and multiply the NO with the reduction part. Okay, multiply the NO with the reduction part. Multiply NO with reduction part and multiply NR with oxidation part, right? So that is going to be we are going to multiply this and this is going to be, everyone, this is going to be, now what we are going to do, multiply this is going to be 2 and this is going to be 4, right? Okay, so we multiply NO. So we multiply NO here, that is 2 and the reduction part, that is 4. So here should we have 4, right? Just wait. So this is the step that I have, like long step they are taking. Okay, I'll just mention it here. Okay, I'll just mention it here. Okay, multiply this with 4 and multiply this with 2. So what is the next step? What is the next step? What is the next step, bacha? Do you really want to test my patience or what? Do you want me to stop teaching? Do you really want me to stop teaching? Now tell me, what do you want from me? Tell me. Am I like stupid that I am standing here like teaching you, or I am doing some dance and all that? What I am doing here? What I deserve to like listen to all this crap here? Have I done something wrong to you? Have I done something wrong to you, mister? No? Why do you want to test my patience here? What do you think? That I'm just a teenager who is here like teaching you, like, you know, I don't have any knowledge or something? I don't have any other work? Do you really feel so? I am bachelor's in chemistry. I have done B.Ed. I have done master's in organic chemistry. I am master's in physical as well as inorganic chemistry. Now what do you want from me? Huh? Just come here, ma'am, please teach electrochemistry. Ma'am, please teach electrochemistry. I thought, let us teach. Okay, let us teach. That is one go, right? But you guys, because you are getting everything for free, no? So there is no like if I tell you that I'll teach you for 20,000, for 50,000, for 60,000, for 1 lakh, you'll say, oh my god, ma'am, please, ma'am, take the class, ma'am, now we are going to, ma'am, please, when we are going to teach us, ma'am, please tell us. Because that is for free, no? So something for free, it loses its value. This is what I see. Okay, so do you want me to think that I should not take your comments seriously? I'll definitely do that. I will not take your comments seriously. I promise you that. Okay, you ask me anything, ma'am, please take this session, ma'am, please take that session. I will not take that seriously. I will do that according to me. Okay, right? Because whenever I take you seriously, this is what happens. Whenever I take you seriously, this is what happens. I'm standing here, no student here. Fine. Okay, so this is 4, right? Okay, so the first step is going to be, the first step that you're going to do here is, first step is to calculate the oxidation number n factor and then reduction number n factor, then multiply oxidation number with the reduction part and reduction number with the oxidation part on the left side. Then third is to balance all atoms except which? Hydrogen and oxygen. Okay, to balance all the atoms except hydrogen and oxygen, right? Okay, yes. Next part is okay, to balance all atoms except hydrogen and oxygen. Next part is if it is an acidic medium, or you will be given the basic medium, right? Or you will be given the basic medium. First, let me drag it here. Okay, so you will be given two things here: acidic medium or the basic medium. Acidic medium or the basic medium, right? Okay, so for acidic medium, what we have for acidic medium, we have multiply. If you want to balance H positive, right, then hydrogen will be balanced by H positive and oxygen will be balanced by adding H2, right? And for basic medium, oxygen will be balanced by OH negative and hydrogen will be balanced by water. Okay, one more thing here, one more very important thing here, that if you have oxygen, if you're talking about oxygen here, so oxygen, in that case you will firstly add the hydrogens, right, and then you will add the oxygen. Okay, then you will add the oxygen. Firstly you will add the water, multiply this, and then, okay, firstly add water, first add H2O, then water, then H positive, right? Then you add H positive here, right? Here what you do, first you add double the amount of OH negative that is required, right? And then you add H2. Now all these things what you have done, right? So we will study that in detail. What is that I have mentioned here. Okay, for example, this is the case. Now I have multiplied this is my oxidation part. I have multiplied NR with this one and NO with this one. So I have multiplied 4 here and 2 here. So that is going to be the right. So this is 4. So I will also multiply this with 4, right? Okay. Nitrogen is 2, so I'll also multiply nitrogen with 2. We don't need to multiply this with 2 because it is also 2 and 2, right? Okay. Next thing here. Now, what are all the other atoms that it has? Magnesium, we have balanced it. Nitrogen, we have balanced it. Rest is hydrogen and oxygen. No other atom that we can see here. We are just left with hydrogen and oxygen, right? We are just left with hydrogen and oxygen. So what we are going to do here, we are just left with hydrogen and oxygen. For hydrogen, how many hydrogen? If I say this is an acidic medium, okay, if I say balance it in the acidic medium, okay, in the acidic medium, right? So what we are going to write here, that in the acidic medium, how many H positive you have here, how many hydrogen you have here. In the left side you have 2 hydrogen and 6 oxygen. In this side you have 2 hydrogen, right? And oxygen, how many? Oxygen, there are so many oxygens, bro. So oxygens are almost like 3 to 6, 6 for 24 oxygen plus 1 oxygen from here, that is totally 26 oxygen. And 26 oxygen. That means you need extra 20 oxygen here. Right? So what you are going to do? You are going to add 20 H2O here. You are going to add 20 water here. You are going to add 20 H2O to get 20 oxygens here. That will sum up to, not here, yeah, here only, yeah. So you will add 20 H2O here, right? So to sum up the oxygens here. So now what is the hydrogen here? So here hydrogen is, now hydrogen are 2 plus 40, right? That is 42. And here the hydrogens are 2 plus, right? That is just 2. Okay. So we're going to add 40 H positive here, right? Okay. Yes. Okay, so this is how you do it. Okay, this is how you do it. Now let us discuss the main question here. Let us discuss the main question, that was just to tell you how you are going to do it. Right? Okay, so I have mentioned the steps here. Now just add it. Okay, now just add the steps here. Okay, let us do this and you will have an idea what I am telling you. Okay, you will have an idea what I am telling you. This is Neet 2018 question, that is Mn2 positive, Mn4 positive. Firstly write it here, MnO4 negative plus C2 plus C2O4 2 negative. Then you have plus H positive plus H positive. Now you are going to balance this, Mn2 positive, Mn2 positive, Mn2 positive, right, plus, then you have CO2 plus water, CO2 plus water. What they ask you to balance this question, okay, what they ask you to balance this one, how you are going to balance this? Firstly, calculate the oxidation part and the reduction part here. So what is the oxidation and what is the reduction part, everyone? What is the oxidation and what is the reduction part here? Yes, so here it is having plus 7 and this is having plus 2. So oxidation state is getting decreased here. That means here what we are going to write, oxidation state is getting decreased. That means that here it will be reduction. Here it will be reduction and here oxidation state is increasing, because here in this case it is having plus 6 oxidation state, that is 2x minus 8 is equals to minus 2, that is 10, that is 6, x is equals to 3, right? This is 3, this is plus 3 and this is plus 3 and that is plus 4, right? So that is increasing, right? Here you have plus 3 and here you have plus 4 oxidation state. Here you have plus 7 oxidation state. So this is oxidation, right? So next part is to calculate the n factor for oxidation and n factor for reduction. N factor for oxidation is going to be, that is number of carbon atoms. How many carbon atoms are here? We have 2 carbon atoms, okay? We have 2 carbon atoms. Take the mod of this, then 3 minus 4. 3 minus 4, that is going to be 2 mod minus 1, that is 1. So n factor of oxidation is going to be 2. And n factor of reduction, that is going to be, here you have 1 manganese, so this is 1, number of atom is 1, so that is going to be 7 minus 2, okay, 7 minus 2, that is going to be 1 into 5, that is 5, right? Okay, yes, beta, definitely you can watch this, definitely. Okay, so this is n. Now what you need to do, you need to multiply this, you need to multiply the oxidation n factor with the reduction part, multiply it here and multiply nr here, okay, multiply nr here, okay, multiply nr here. This is the nr part, this is the nr part, that is the reduction part here, right? Okay, so this is the oxidation, this is the reduction part. Now next thing is, just multiply this here, that is NO is 2, this should be 2, right? Okay, I am going to multiply this here, this should be 2, okay, and what is this? This should be multiplied by NR, that is 5, here, okay, that is 5 here. Now let us see, let us balance it out. It has 2 manganese here, 2 manganese here also, right? Then you have 5, you have 10 carbon atoms here, multiply this by 10, okay? Now you have balanced all the other items except for hydrogen and oxygen, right? You have balanced all the other atoms except for hydrogen and oxygen. Now beta, what is left with you? You have balanced all the other atoms except for hydrogen and oxygen. So now let us see how many hydrogens are here. How many hydrogens are present here? Hydrogen is 1. And how many hydrogens are present here? That is 2. Right? How many hydrogens are present here? That is 2. How many oxygens are present here? Oxygen is 8 plus, that is 5 for 20. Right? So that is going to be 28 oxygens. And how many oxygens are present here? That is 21 oxygen. 21 oxygen. Because you have this one, okay? Because you have this one. See, let us not include water and this into this. Okay? See, the best way to do this is not to include H positive and H2O, right? While calculating the hydrogen and oxygen, right? So now let us calculate the hydrogen. There is no hydrogen present here. There is no hydrogen present here, okay? How many oxygen are present here? The oxygen present here are 4 to 8 plus 5 for 20. That is 28 oxygen. How many oxygens are present here? That is 20 oxygen are present here. That means you need to add water in acidic medium. What you do? If this is the acidic medium, they have mentioned the acidic medium here, right? They have mentioned the acidic medium here. So for acidic medium, what you are going to do? For acidic medium, I'll teach you two things here, okay? For acidic and for basic medium. For acidic and for basic medium. For acidic medium, how you are going to add this? For acidic medium, you just need to do one thing, that is add the water first, okay? So as I told you earlier also, for acidic medium, add the water first, then H positive for acidic medium, right? So add the H positive water first. This is 28. This is 20. So we need 8. We need how many oxygen? We need 8 oxygen. That will be provided by 8 water molecules. So add 8 water molecules here. Add 8 water molecules here. So how many hydrogens are needed here? 16 hydrogens are needed. So add 16 H positive. Right, that is in the acidic medium, okay? That is in the acidic medium. That is in the acidic medium, right? So answer is going to be 2 5. This is 2 5 60, right? So this was the correct answer. You had this. This is 2 5 and 60, right? Okay. Now, bacha, next thing is basic medium. Next thing is basic medium. Okay, next thing is basic medium. How are you going to do that? For basic medium, everyone, for basic medium, add OH negative, double the amount of OH negative plus water. Then you add water here. Okay, this is for basic medium. This is for basic medium. So students, this is having 28 oxygens. This is having 28 oxygens. So firstly, I will balance the oxygen atom by adding OH negative. Okay, by adding OH negative. And to add OH negative, I should add the double the amount of difference. So how many oxygen is needed? 8 oxygen are required. Okay, this is having 28. This is having 20. So 8 oxygen are required. So I will add double the amount of oxygen that is required. So I will add 8 OH, I will add 16 OH negative, right? I will add double the amount of oxygen that is required, plus I will add water here to balance out the oxygen here. Oxygen is balanced, so then I'll add H2O here. Yes. So how much H2O will I add? I will add the half of H2O will be divided. Okay. I will add H2. See. Wait. You have added double the amount of OH negative. Now how much water will be added? Half the amount of OH negative that you have added here. That is 8 H2O will be added. So in that case, you will have the balance. There will be balancing because it has 16 H positive, 16 H positive, 16 hydrogen, 16 hydrogen. It has oxygen are also balanced because we have added the oxygen also. Right? Okay. Yes, bacha. This was the tricky part in the basic medium, that you add. Then you calculate the difference. You calculated the difference. This is the difference. This is the difference. Okay. You add OH negative should be double into difference. double into difference, and H2O should be equals to the difference. It should be equals to the difference. Okay, that should be equal to the difference. Yes. Okay, students. Yes, so this is how you balanced it. Yes, everyone, any doubt here? Now, as I told you that by 3 o'clock we will complete our redox reactions. After this, we are going to start with electrochemistry. After this, we are going to start with electrochemistry. Okay, we are going to start with electrochemistry, and that will be at, yes, okay. So I am going to start electrochemistry at 3:15 p.m. Okay, I'll also have my lunch. After that, you also have your lunch, and then we are going to start the electrochemistry at 3:15 p.m. right? And then that will be a stretched up lecture where we are going to complete the whole electrochemistry, right? Okay, yes, okay. So I am going to apply the, I'm going to add the timer here, and then I'll see you after the lunch. Okay, students? Yes. Okay, then see you at 3:15 p.m. Okay, everybody. Oh my God, what I just did. I didn't set the timer. Oh God. So hi everyone, welcome back, welcome back. Now we are going to do electrochemistry. So are you all ready for electrochemistry? Is everyone here? Are you all ready or not? Can we start the electrochemistry part, or we should not start the electrochemistry part? Right? Everyone here, shall we start the electrochemistry part? Yes, students, shall we start the electrochemistry part? Be little responsive as I told you how to type. I'll tell you. This is your phone. Okay? This is the Vedantu Neet English. Okay? Click it here. Then you go to this. Okay? Yes, I'll teach you. All the students are very non-responsive. To all that, I'll teach you how to type. Okay? I'm your teacher. So guys, what you do here, this is my lecture and this is the live chat here. As you can see, this is the live chat. And here you do this and this is the alphabets. Okay? So you write, okay. This is how you write. Okay? This is how you write. And then you send the message. Very simple, not very technical. Okay? Very simple, not very technical. Okay, it just takes you some seconds. Someone is standing here for you, right? So all the students who are present but still very non-responsive, better don't do that. Okay, that really, drains my energy as well. So be responsive. Be little responsive and have some, that thing, okay? Yes, ma'am, we are going to do this. Yes, ma'am, let's do electrochemistry. Have some energy, okay? Have some energy in you. Okay, guys, so Sumiti, Mohammed Zain, Raje, Neet aspirant, all these people are, I think, enthusiastic. Other than this, they're very lazy. Oh my God, they just want to sleep. Okay, so let us start the electrochemistry. With electrochemistry, bacha, we have two cells here. That is what you make me feel like the typing is much difficult for you as compared to NEET exam, is it? So you just need to write, okay ma'am, yes ma'am, that's it. If you have any doubt, and then ask that doubt. Okay, at least I should not feel like that I am teaching these lights and this digital board and these setup that I'm teaching this camera. Don't make me feel like that. I want to make it feel like electrochemistry will be very easy. This is my most favorite chapter. Very simple chapter, very easy chapter. Okay, yet students feel that this is a difficult chapter, but student, this is not a difficult chapter. Okay. Yes. Now we have electrochemical cells. Two type of electrochemical cells. First one is galvanic cell, right? First one is galvanic cell, and other one is electrolytic cell. Okay. So now students, let us see what is electrochemical cells. Or you can just define it. It should not be like this. Wait. This should not be definition of electrochemical, right? So these are the types of electrochemical cells only, right? These are the type of electrochemical cell. This is electrochemical cell, and these are the two kind of things that we are going to study in electrochemistry, right? Two things that we are going to study in electrochemistry is electrochemical cell and electrolytic cell. Electrochemical cell is that which converts chemical energy to electrical energy. Okay, which converts chemical energy to electrical energy. That means it converts chemical energy to electrical energy. And electrolytic cell is that which converts electrical energy to chemical energy. Right, so these are the differences. This converts chemical to electrical. This converts electrical to chemical energy. Right, okay. And see, this galvanic cell or electrochemical cell is spontaneous cell, and this electrolytic cell is non-spontaneous cell. When we say chemical energy is getting converted to electrical energy, that is spontaneous, that happens by itself. It does not need any initiation. But when we say electrolytic cell, that needs some initiation. That means it is a electrolytic cell. It is a non-spontaneous cell, and for non-spontaneous cell, delta G is positive, and here delta G is going to be negative. That is for spontaneous cell, delta G is going to be negative here. Next, students, let us talk about the first thing. Firstly, we will discuss about the electrochemical cell. Then, students, we are going to discuss about the electrochemical cell. Okay. Yes, students. So, two type of cell we are going to discuss. First, we are going to discuss about the electrolytic cell. Under that, we have Daniell cell. Okay. Under that, we have Daniell cell. So, now let us see what is Daniell cell. Right, okay, so you have two beakers. See, you have two beakers. In one beaker you have this metal electrode, and the same electrolytic. If you have a metal electrode, the salt with that metal, right, you will have salt with that metal that is deposited here, right? So you will have this metal electrode, the salt of that metal electrode, this metal electrode, and the salt of that metal electrode, right? So what we are going to do, we are going to see how this is going to generate the electricity, right? So see this, students, in this case you have ZnSO4, that means there will be Zn 2 positive ions, that means there will be Zn 2 positive ion and SO4 2 negative ions. Here it will have Cu 2 positive ion and it will have SO4 2 negative ions, right? And it will have Zn, right? Okay, so see this, students, you just need to remember this is the oxidation part, this is the reduction part. Left LOAN, always remember lone, always remember lone. What is lone? Lone means loss of electron. Always remember lone here, that means LOAN. Lone, students, what do you mean by lone? LOAN. Lone means for electrolytic cell, this means loss of electron on left side, right? That is oxidation. That is oxidation. That will be at anode, and that anode is going to be a negative electrode. That anode is going to be a negative electrode for electrochemical cell. Anode is a negative electrode for electrochemical cell, and it is a positive electrode for electrolytic cell, right? So here we are going to talk about electrochemical cell. So anode is negative. So what happens here? What happens here? At anode, students, what we have? Everyone, at anode we have loss of electrons. Is it? At anode we have loss of electrons. That means this Zn2 positive ions we have, and we have this zinc. Here we will have loss of electron. What means? That means zinc from the rod, it is going to lose the electron and it is going to disperse itself into the solution, right? And there will be loss of 2 electrons here. But at cathode, what you will have? At cathode, students, what you are going to have? At cathode, Cu2 positive ions in the solution, they are going to gain 2 electrons and they are going to get converted into Cu. That is the rod. Okay, that is the rod here. Okay, that is the rod here. Okay, so it is going to get converted into Cu. That is the rod here, right? So what is happening in this case? This means that the zinc electrode is getting thinner here. Okay, this is getting thinner here because it is losing the Zn in the form of Zn2 positive ion. It is losing the zinc in the zinc solution, and this whole solution is going to have more positive charge here because now there are more positive ions in the solution, and it is going to transfer the electrons here. The electrons will move this side. Okay, the electrons, because of that the bulb is going to glow here, and here in this part at cathode side, at the reduction side, the electrons, the Cu2 positive ions are going to get the electrons and they will get converted into the copper electrode, and this copper electrode is going to get thick here. Okay, and the copper electrode is going to get thick here. This will get thin. At a node, zinc electrode thin, it will get thin, and copper electrode will get thick here. It will get thick here. Okay, zinc electrode is going to get thin and copper electrode is going to get thick here. Yes, students. Okay. Yes. Next is now, ma'am, what is the use of salt bridge here? Right, this is getting thinner, this is getting thicker, and this whole solution is getting more positive charge. This whole solution is getting more negative charge. Why? Because copper is getting converted to copper rod, and there are SO4 2 negative ions in the solution. That means to balance the electrical neutrality, we have to do something, right? To do something is that we need to add the salt bridge here. So this is the salt bridge that we are going to add. And now what is the function of salt bridge? Salt bridge is nothing but it is a U-shaped thing. It is a U-shaped tube, right? And it has agar-agar solution, and it has agar-agar solution in it. It is a U-shaped tube. It has agar-agar solution in it, and it also has cotton balls in the end. That means cotton ball is present here. Cotton ball is present somewhat here. Now, what is the reason that it has cotton balls, right? So as you all know that electrons, okay, so this whole part is positive and this whole part is negative, right? So to maintain the electrical neutrality, the anions are going to go on the oxidation side and the cations are going to go on the reduction side. So they can also ask you this, okay, the anions are on the oxidation side, the cation are on the reduction side, right? Okay, so what kind of electrolyte? An electrolyte is going to, we are going to add a salt, an electrolyte in the salt bridge, which is going to maintain the electrical neutrality of oxidation and reduction half cell. This is the oxidation half cell, this is the reduction half cell. Where oxidation occurs, that is oxidation half cell. Where reduction occurs, that is the reduction half cell. Right? So let us see. Earlier what you used to say, that now there is one condition for salt bridge. That condition is the mobility of cation should be equal to the mobility of anion. Only then there will be there will be electrical neutrality. For example, if you talk about KCl, KNO3, all these have electrical neutrality. Okay, all these have electrical neutrality, right? Okay, so the direction of movement of electron is from zinc to copper. As you all know, the direction of movement of electron is from this part to this, that is from zinc to copper, right? In the Daniell cell, in ordinary condition, the electron movement is from zinc to copper. The current movement, the movement of current is to the opposite direction of the flow of electrons, right? That is going to be from copper to zinc, right? Okay. Now, students, next thing here is they are talking about this only, salt bridge only. Due to oxidation occurring at zinc, it becomes source of electrons, acquires negative charge. Okay, it becomes a negative charge. Due to reduction occurring at copper, it becomes receiver of electrons and acquires a positive charge in the cell. Okay, so this acquires a positive charge, this acquires a negative charge. So to maintain that, we need to add the cations and anions in that side. Okay, yes. Now, next is, students, very important. That is, if you apply the external voltage, now what is going to happen? Now, three things are going to happen if you apply the external voltage, okay? If you apply the external voltage, if the external voltage is more than 1.1, if the external voltage is equal to, this is for Daniell cell, okay? And if the external voltage is less than 1.1. If someone from the external side is more than 1.1, everyone, if the someone from the external side is more than 1.1, then what you are going to say is someone from the external side is more than 1.1. In that case, we will say that it is the current, the flow of electron is going to get reversed. Okay, the flow of electron is going to get reversed. In this case, the cell is going to stop. Okay, and if external voltage is less than 1.1, in that case it is going to remain the same. That means electron flow will be from copper to zinc here because there is reversal, and current flow, that is current flow, is from zinc to copper, right? That is the opposite of it. Electron flow, no flow of electron, no flow here, and here it is going to get same. Electron flow is from zinc to copper, that was same in the Daniell cell, and current flow is from copper to zinc. Yes students, any problem here? Any problem here? Any problem on this side? Any problem here students? So here we have Daniell cell, that is this the external voltage, this is the internal voltage. If it is less than this, then this will form exactly the same, that is electrons will be from zinc to copper, right? Nothing will change here. If it is equal, there is no flow of electrons, no chemical reaction occurs, and that is more than, then it will get reverse. Okay, then it is going to get reverse here. That means the electron flow will be from copper to zinc here, right? If the voltage is more than that, only that it will get reverse here, right? Next is about the electrodes. Okay, as I already told you, there are two type of electrodes, anode and cathode. Anode is where oxidation occurs, right, and cathode is where reduction occurs. And in case of electrochemical cell, anode is the negative electrode and cathode is the positive electrode. Okay, anode is the negative electrode and cathode is the positive electrode, right? You just need to remember one thing, that is LOAN. As I told you, right, that is for electrochemical cell. Loss of electron at oxidation at anode, right, which is a negative electron, and that too in the left side, right? Okay, yes students, now let us see how to represent the cell. Okay, now let us see how you are going to represent the cell here. Now let us see how you are going to represent the cell here. Okay, sweetie, what are you doing? I can see your deleted chats. Okay, so now see this Daniell cell representation. Let us see how you are going to represent the cell here. See this, firstly their left side will be the anode side, this will be the cathode side, this is going to be the cathode side, and this salt, and this represent the salt bridge, this represent the salt bridge. For example, we have something like this, this zinc is losing the electrons and copper is gaining the electrons, So how to represent this in the form of cell representation? Okay, firstly at this side you will write, there will be a salt bridge here, right? At this side you will write the oxidation part, that means where there is loss of electron. Loss of electron is from zinc to zinc positive, so you will write zinc positive, right? And as these both are in the same state, they are in the opposite state. This is the solid part, this is the aqueous. This is the solid part, this is the aqueous part. So there will be one single line here, right? And you are going to write here, this is your zinc. This is what you are going to write here, that is the solid part. This is the aqueous solution, right? And in this side you are going to gain the electron. The copper is gaining the electron, so it will Cu2 positive and Cu. Here this is the aqueous solution and this is the solid solution. Okay, this is the aqueous solution and this is the solid solution. Okay students, this is the aqueous solution, this is the solid solution, right? Okay, understood? Ma'am, means phase change. Yes, whenever there is phase change, you are going to define it by one single line here. When there is no phase change, for example, I have something that is, for example, I have a cell that is A positive to A. This is also aqueous, this is also aqueous, right? This is B to B positive. This is aqueous and this is solid. Now how I am going to represent this? Firstly, draw the salt bridge here. Which is losing the electron? Which is losing the electron? This is losing the electron. So B, this is solid, this is aqueous. So this will be represented by 1. If there is phase difference, that will be represented by one single line. If there is no phase change, this is aqueous, this is also aqueous. So I'll write it here. Gain of electron, this is positive. This will be represented by comma. This will be positive. Aqueous, A, aqueous. Okay, when there is no phase change. Right? Okay? Yes. The line means phase change. The double line means salt bridge. This double line means salt bridge. This means salt bridge. Okay, this means salt bridge. And this means phase change. This means phase change. This means there is phase change. Right? Okay? Yes, students. Now let us do the next part here. This is the salt bridge. We have already done that. Right? Okay. This should be somewhere here. Okay, this should be somewhere here. Just give me a minute. Okay, let us read the salt bridge. Okay, some definitions of salt bridge, some important points of salt bridge. That is U-shaped, already done. Completes the circuit by facilitating flow of ions. Semi-solid paste of agar-agar solution like KCl, NH4Cl, KNO3 in the agar-agar solution or the gelatin. Okay, to smoothen it. Okay, so that we don't want it to flow just like that. We want the speed to be very slow. Okay, for that we have added agar-agar solution or gelatin. Ends the salt bridge plugged with glass wool. As I told you, this particular here it will be glass wool to stop the flow of the ions, to just decrease the flow of the ions. Right? Next thing is ions does not react with ions of electrode. Very important point, that the ions of salt bridge should not react with the ions of electrolyte here. Right? Salt bridge maintains electrical neutrality and flow of current. K positive ions move to cathode compartment. Right? As I told you, the cations will move to this part. The cations are going to move on this part, and the anions are going to flow on this part. Right? So all the points that we discussed are written here. Okay, all the points that we discussed are written here. Now let us see the electrode potential here. Okay, now let us see the electrode potential. This is a very important thing. Electrode potential, Nernst equation. Definitely they are going to ask you question. Okay, no paper of chemistry is made without asking, like if there is electrochemistry in the syllabus, no paper is going to exclude Nernst equation or electrode potential from this. Okay, so they are definitely going to ask you question from this. So let us see this. Electrode potential. What is the electrode potential, students? As I told you, this is the beaker. Okay, this is the beaker. There is the U-shaped salt bridge here, and here we have the electrode. Here we have the electrode. So what is going to happen here? Let me draw it a little bit neatly. Okay, so you have the beaker here. You have the beaker here, and here you have this electrode. And here also you have this electrode, right? So what is going to happen here? This electrode is going to get positive charge here, right? There will be negative charge here from the solution. For example, see this. As I told you, this is the oxidation part. This is the reduction part, right? Okay, this is the oxidation part. This is the reduction part. I told you that the electrons are flowing from this side to this side. Okay, there is flow of electron here, right? Okay, so that means there is negative charge here. There are flow of electrons from this part to this part, right? Okay, so and the solution here is positive, and the solution is turning positive here. So because of that, we have, because of this difference in the charge, we have the electrode potential, right? We have the electrode potential because of this difference in charge. Because of this difference in charge, because of this difference in charge, because of this difference in positive and negative charge, we have electrode potential. We have electrode potential. Okay, what we have? We have electrode potential here, right? So let us see this. Now how you define the electrode potential? The electrode potential of the oxidation side is called electrode potential of oxidation, and the electrode potential of reduction side is called electrode potential of reduction. Okay, yes everyone, that is calculated experimentally, right? Okay, always remember that oxidation potential, if you are talking about one single element, in that oxidation potential is always negative of reduction potential, right? For example, if I want to calculate the E cell, that means I have the oxidation potential, I have the reduction potential. Now I want to calculate the total electrode potential of the cell. How I am going to calculate that? That will be E of anode plus E of cathode, plus E of cathode here, right? E of anode plus E of cathode here, right? Okay, so then next what you have? E of anode plus E of cathode. See this, next what we are going to have? E of anode will be, students, E of anode will be, this is going to be E at oxidation plus E at reduction, right? For example, at anode I have a metal that is M. Okay, I have a metal that is M. I have a metal that is N, right? Okay, here I am talking about M, here I am talking about N. As you know, oxidation potential is reverse of reduction potential. So I'll write minus EM reduction potential. Can I write something like this? EN reduction potential, right? Can I write things like this? So now I have converted the E cell into the reduction potential that is happening at cathode. Okay, now I have converted it like this. Now, next thing is, this is at cathode, this is at cathode. I have answered this in the reduction potential of both, right? M is on the, for example, I am talking M is at the oxidation, where the M is at the anode side, right? And N is at the cathode side. Okay, N is at the cathode side. For example, here I say this is M and this is N, right? Okay, this is the anode side, this is the cathode side. So can I write here minus E of anode reduction potential plus E of cathode reduction potential, right? Okay, so from this you have one formula that is used, right? And students do big mistake in the exam. What they do is E naught cell, they just cram this thing that E naught cell is equals to E reduction, E cathode minus E anode. E cathode, you must have heard about this formula, right? E anode. But now what they do mistake in that E cathode and E anode are the reduction potential. The reduction potential of cathode and the reduction potential of anode. We are talking about the reduction potential of cathode and the reduction potential of anode. We are not talking about the oxidation potential, right? Okay, so how reduction potentials are mentioned? Reduction potential is mentioned by, for example, if I am talking about reduction potential, that will be mentioned by E of A positive to A. And if I talk about oxidation potential, that will be mentioned by E of A to A positive. Here will be have loss of electron, here will have gain of electron. And always E A positive to A equals to minus of E A A positive. Right? Okay. Students here, do you have any confusion till now? Any confusion here? Any confusion? Yes, students, any confusion here? Let us do one example of that. This is a standard, okay? When we do the numericals now, you will get more clarity on that. Okay, so this is the standard electrode potential that is mentioned by naught, that is 0, naught. Okay, so that is having concentration 1, gases it has 1 molar pressure, and temperature is always 25 degrees Celsius, that is 298 Kelvin. Okay, if nothing is mentioned about the type of electrode potential, it is assumed to be reduction electrode potential. Usually, reduction electrode potential is taken as the standard electrode potential. Right? Okay? Yes. Next thing, already done. See, now this is very interesting for you. Now this is going to be very interesting for you. This is the reaction. Okay, shall I erase everything here? Okay, so that we can also ourselves write this. What if they give you a reaction? Usually what they do, they will give you a reaction like this. Okay, you have to calculate everything. They will give you just one reaction and you will have to calculate everything. You will just have to judge everything here. Okay, firstly, what do you mean by this one? So here you see that here we see there is gain of electron. There is gain of electron means there is reduction at this point. And there is reduction at this point, and here we see loss of electron. That means here we have oxidation. Okay, that means here we have oxidation. Here we have oxidation. That means, can we write that reduction is at, okay, oxidation. Oxidation means anode. Oxidation means anode. That means at anode you have loss of electron. That is, copper is getting converted to copper 2 positive by losing 2 electrons. Right? At reduction, when there is reduction, that means at cathode you have the Ag positive is getting converted to Ag, right? That means after gaining the electron. Now, another important thing here is that the N factor, that means the number of electrons gained and lost, right? That should be equal. If this is losing 2 electrons, it should gain 2 electrons also. So I'm going to multiply this by 2, I'm going to multiply this by 2, I'm going to multiply this by 2. That is why this is the proper reaction. We have multiplied Ag with 2 and 2 Ag here. Why? Because number of electron lost and gained in the chemical reaction should be equal. Okay, that should be equal. Now next, students, right? Now let us represent this with the help, right? Let us represent this. This is the salt bridge, right? At this point we write the oxidation, that is on the left side. So this is Cu2 positive, right? And here we have Ag positive 2Ag, right? Okay. So this is the cell representation. Next thing that we have here is, what is the E cell? What is the E cell here? E cell here will be, what is the cathode part? Cathode part is the Ag. Okay, so we'll write it as E of reduction potential of cathode, that means Ag positive 2Ag minus E of reduction, E naught cell is going to be E naught Ag positive 2Ag, reduction potential of anode, that is the oxidation potential will be Cu2 positive, right? That is loss of electron. But the reduction, this is the oxidation potential. The reduction potential is going to be Cu2 positive to Cu. This is going to be reduction potential. Yes, everyone, this is going to be oxidation potential when there is loss of electron, and this opposite is going to be the reduction potential. So I'm going to write reduction potential at anode side. Anode we have copper, so that is Cu2 positive 2Cu. Okay, this is will be your E0 cell. Yes everyone, very good afternoon, very good afternoon. Ma'am, please go little slow. Okay bacha, I'll go little slow. Okay, any problem till now? Any problem here? Any problem here? I'll teach you again. Okay, see, you have this reaction. Okay, here you have loss of electron. That means this is the zero oxidation state. It is +2 oxidation state. That means the oxidation number is decreasing. That means the oxidation number is increasing. That means there is oxidation. Here we have, this is +1 oxidation and this is 0. That means the oxidation number is decreasing here. That is the reduction part here. The oxidation number is decreasing here. Okay, that is the reduction part. Okay, so that is the reduction part. Here we have oxidation. At oxidation, we have oxidation at anode and we have reduction at cathode. Right? Okay, that is represented by LOAM. LOAM means loss of electron at anode when there is oxidation, and anode is the negative electron. Loss of electron means oxidation which happens at anode, and anode is a negative electron. Right? Okay? Yes students? Yes students? Yes bacha? Yes Archana? So students, this is oxidation, this is copper to copper 2 positive. Now this is the reaction here. After that, how I am going to represent this? Salt bridge is always, this is the oxidation part, right, and this is the reduction part. So I will represent it. This is the oxidation, loss of electron, this is the gain of electron. But when we have to calculate the E0 cell, we mention the reduction potentials here. That means E0 cell is equals to E0 reduction, wait. Reduction is happening here, reduction is happening here. That means it is reduction potential will be gain of electron Ag positive to Ag. Minus reduction potential at anode. At anode you have this one. There is loss of electron. So if you write E of Cu to Cu positive, that is oxidation potential. Reduction potential is opposite of oxidation potential. Yes students? Okay. Is this clear to you? Let us do the She here. Let us do the She here. Standard hydrogen potential, that is She. What is She? She is this, okay? She is us, she is C. Okay? As she is helping everyone here, okay? She is helping for which class you are asking? For which class you are asking? Okay? So this is the standard hydrogen electrode, that is SHE. Okay? So SHE, standard hydrogen potential, what you do? We calculate the hydrogen potential for the hydrogen. Okay, reduction potential for the hydrogen. Either we calculate the reduction potential or we calculate the oxidation potential. Then we define the reduction potentials for other elements. Okay. Then we define reduction potential for the other elements. That is this one. So here, if you say that H positive is gaining electron, that means we are going to put it in a situation when you have hydrogen is acting as the cathode. Okay. It is gaining electron. Hydrogen is acting as a cathode. This is the She. If she is, she is in a situation with something, that is, if she is regarded as a if she is at the reduction side or it is at the cathode side, then the other metal is going to be at the anode side. Okay, right? If I say I have calculated that hydrogen is at the cathode side, means there is a reduction here. Okay, then the other metal will have the oxidation here. And what we use in She? We use platinum electrode. And we use platinum electrode, H positive ions, that is 1 molar H positive ion, and H2 gas here. Right? So there is reduction in this case. And students, if we say, see this here, if I say I want to put the hydrogen as the anode, okay, I want to put the hydrogen as the anode. Okay, if I say hydrogen is at the anode, then the other electrode will be at the cathode side. Okay, Yes, the potential in a half cal cannot be measured and hence it is calculated against SHE. In relative to SHE, we calculate the electrode potential for other things. If we have defined, see students, if hydrogen is the cathode, then we calculate the electrode, then we calculate the oxidation potential of metal, of any metal that is represented against SHE. Okay, if hydrogen is the anode, if hydrogen is on the anode side, some other metal is going to be on the cathode side. That means here you are going to calculate the reduction potential of that metal. Okay, so how you calculate the reduction potential? When you say she is the anode, then you calculate the reduction potential. When she is cathode, then you calculate the oxidation potential of the metal. Yes students, then you calculate the oxidation potential. I don't know yaar, whether to switch on the AC or to switch off the AC. This is what I am doing these days, right? Okay, understood this? If she is at cathode, see this, if she is, right? See, there are two things that are possible here. If I say she is on the anode side, if she is on the anode side, then we calculate that this is on the anode side. Then at cathode side we have a metal. Okay, here we have hydrogen and here we have a metal. Then we calculate the reduction potential of metal. Metal is calculated. Okay, but if this is the anode and this is the cathode, and this is the cathode, and this is the cathode, and she is on the cathode side, she is on the cathode side, here she is on the anode side, here she is on the anode side, she is on the anode side. If it is on the cathode side and metal is on the anode side, then we calculate the oxidation potential of metal is calculated, and as you know, oxidation potential is negative of the reduction potential. Yes, okay. Now let us do the formula, let us do the question here. That is 2011 question. 2011 question students, 2011 question. Standard electropotential of this occupies, okay, this is standard electrode potential. Is this reduction or oxidation? The 4 positive is the oxidation number is decreasing. That means they are talking about the reduction potential. Reduction potential is this much, and that for this couple is this much. Here they are talking about the reduction potential again, right? These two couples in the standard state are connected to make a cell, the cell potential. See, E naught cell will be equals to E naught cathode minus E naught anode. So everyone, they have given you the reduction potentials here, right? You have to calculate, you have to see which will act as a cathode and which will act as a anode, right? You just subtract it and you will get your answer, here, right? Just subtract these two things here. Just subtract these two things. 0.74 minus 0.15. That is going to be what? That is going to be something 6 minus 1. This is going to be Everyone, what is going to be the answer here? Both, they have given the reduction potentials of both, right? So cathode minus anode, right? What is going to be the answer? Just subtract this and you wait. We are going to subtract this. No. So electropotential of this couple is this. Okay, there is decrease in the oxidation number, there is decrease in the oxidation. Oh, Bicha, this is minus, right? This is positive and this is minus. So what you do? 0.15 minus 0.74 and just add it, you will get your answer. Okay, just add it, you will get your answer. Okay, that was negative. Right? Cathode minus anode. Right? Cathode minus anode. This is the cathode part and this is the anode part. This is the anode part. You don't know, ma'am, how you said that this is the cathode part, this is the anode part. You don't even need to know what is the cathode part, what is the anode part, because see, if you subtract this thing here, you will get only this one. Only here it is getting adding on, right? Otherwise, you just need to subtract these two things. Either you put it like this, either you put it like that. Okay, the answer is going to be the same. If you separate it like this, minus 0.74 minus 0.15, the answer is going to be minus 0.89. There is no option for minus 0.89, there is option for 0.89, so answer is going to be this one. Okay, yes, simple. Okay, so this is the reactivity series, right? If you see this, here you have, this is the reactivity series, wait. So here, see, you have this, see, few things that can be asked from this is that this is the strongest oxidizing agent and this is the weakest oxidizing agent. Why so? Why so? And this is the weakest reducing agent, this is the weakest, this is the strongest reducing agent. So see this, students, this is in the see, one thing here, that reduction potential is inversely proportional to the reducing power, and that is directly proportional to the oxidizing power. And that is directly proportional to the oxidizing power. That is directly proportional to the oxidizing power. Okay, so that is directly proportional to the oxidizing power. This is the reducing power, inversely proportional to reducing, directly proportional to oxidizing power. For example, I am saying that if they can ask you in the reactivity series, this is the strongest oxidizing agent. Like it has it has the largest electrode potential. The reduction potential is largest. Okay, this is the series of reduction potential. It has maximum reduction potential. It has maximum reduction potential, and more is the reduction potential, more is going to be the oxidizing power. That is, it is the strongest oxidizing agent, right? And here it is having the least reduction potential, and that is why it is going to be the least oxidizing agent. It is going to be a very weak oxidizing agent, right? So you just need to remember this thing and this thing, that fluorine and lithium. This is going to be very good oxidizing agent. This is weak oxidizing agent. That's it. Okay, that's it. Okay, they can ask you questions from this part. Okay, students, now let us see this. Now, bacha, we have already completed the syllabus. Okay, Nandani ma'am has taken the class of chemical bonding. That is already done, right? Okay, yes. Electrochemical series. So this is electrochemical series. Species at higher positions. So see this. Okay, we have already covered this. Okay, we have already covered this. The part is this one. Okay, reduction potential is inversely proportional to reducing power and directly proportional to oxidizing power. We have already done this part. Okay, already done this part. Next here is the question. NEET 2019 question. Everyone, NEET 2019 question. The standard electrode potential values of Al3 positive, Alg positive, Ag. You have given you the standard they have given you the reduction potentials of all, the correct decreasing order of reducing power. Okay, so that is inversely proportional to the reduction potential, right? That is inversely proportional to reducing power is inversely proportional to the reduction potential. Okay, inversely proportional to the reduction potential, right? Okay, students, so that is inversely proportional to the reduction potential. So reduction potential for which is maximum, you can see the reduction potential for Eg is maximum here, right? So that is going to have maximum, that is going to have minimum, that is going to have minimum reducing that is going to have minimum reducing power, right? And then we have for chromium, then about potassium and aluminium, which has the minimum reduction potential. Which has a minimum reduction potential? That is potassium. So answer is going to be C, right? C is going to be the correct answer, right? Simply apply this thing, okay? Okay. Wait, students, I'll see that, I'll watch it out. If that is in the playlist or not, I'll let you know about it. Okay, I'll let you know. Okay, yes. Now, next we have the formula, very important. What is the electrical work? Okay, what is the electrical work here? So just remember about this formula. You just need to remember this one formula. That is this one. Okay, you just need to remember this formula. No other formula is needed. Okay, no other formula is needed. You just need to remember this formula. That's it. Okay, for your questions, just remember this formula. Always remember this. This is the maximum work done also. Maximum work done also. Maximum work done, or they ask you Gibbs free energy, that is going to be minus NF E cell. Okay, minus NF E cell. And from this equation, we are going to derive the Nernst equation here. Okay, and for standard condition, that will be delta G naught is equals to minus NF E naught cell, right? Okay, and at equilibrium, write it here. The questions, they ask you questions from this part. Okay, at equilibrium, delta G is equals to 0. Okay, not delta G naught, delta G is equals to 0 at equilibrium. Okay, at equilibrium, delta G equals to 0. Okay. Yes, students? Yes? Okay. Next is Nernst equation. So now, let us see the example here. Very important, very important question. PYQs are asked, previous year questions from this particular thing is asked, okay? So what they ask you, what is the meaning of this thing? E naught is, E cell is the intensive property and its value does not depend on the stoichiometry. It is an intensive property. They are saying it is an intensive property. That means it is non-additive. Okay, it is non-additive. It is non-additive. Right? That means if I say that you have E cell, E1 cell and E2 cell. If you combine these two cells, what is going to be the value of E3? It should not be equals to E3. That means E nu is not equals to E1 plus E2. That is not additive. That is not additive. But if we talk about delta, that is an extensive property. Delta G nu equals to delta G1 plus delta G2. Okay? Yes, students? Okay? For example, if we talk about this example, okay, here I have multiplied this with 2. Okay, I have multiplied this with 2. So delta G is going to change here, that it will also be multiplied by 2. Okay, it depends on the stoichiometry coefficient. Right? Okay, now let us do this example. That is from your 2019 question. that is based on this. For a cell reaction, the cell reaction, you are given E naught cell is this, the standard Gibbs energy of the reaction. Okay, they ask you the standard Gibbs energy of the reaction. Very simple. Delta G naught is equals to minus NF E naught. Right? What is E naught here? What is E naught cell is given to you? E naught cell is given to you. And how many electrons are lost or gained here? Fe3 positive is getting converted to Fe2 positive. Right? There is one electron. And I negative is getting converted to I2. There is one electron. Two electrons here. 2, 6. It has 6 plus 6. It has plus 4. So N is going to be 2. Right? Or you can also write it something like this. If you don't want to do this shortcut method. Or you can write it something like this. That Fe3 positive is getting converted to Fe2 positive, right? And I negative is getting converted to I2, right? So it is going to lose one electron here, right? And if this is 2, this is going to lose 2 electrons here. That means here we should add, okay, wait. And it is going to, what is I negative to I2. Right, so this is minus 1, this is going to lose electron and this is going to gain the electron. Wait, this is going to gain electron, that is 1 electron. It is going to lose 2 electrons. It is going to, if this is 2 negative, right, this is, see, this is I negative to I2, right? So 1 I negative is going to lose 1 electron here, right? And 2 I negative, because there are 2 atoms, so 2 I negative is going to lose 2 electrons here. If this is 2 electrons, this should also be 2. If this is 2, this should also be 2. If this is 2, this should also be 2. Okay, so that should be 3, 2, 6 and this should also be 2. And here to sum up this, you have this equation. So N factor comes out to be 2 here. Right? Either you can do this way or you can just apply the shortcut here. That is 3 into 2, that is plus 6, and this is 2 into 2, that is plus 4, that is 2 electrons. Here also you have 2 electrons. Okay, but this question they have given you the balanced equation. Otherwise they might not give you the balanced equation here. Okay, just apply this formula, that is delta G naught is equals to minus NF E cell. Okay, N value, F value is 1 Faraday, that is the 96500 Coulomb per mole, and then apply this and you will get the answer. Okay. Yes, students. Okay. Next, students, we have Nernst equation is valid. Okay, Nernst equation, just apply this Nernst equation here. Okay, just apply the Nernst equation here. See, what is Nernst equation? What is Nernst equation, students? That is E cell. Everyone, what is Nernst equation? That is E cell equals to E naught cell minus 0.0591 by N, right? Log base 10 oxidation by reduction. Okay? Yes? Okay? Or you can write it as E cell, E naught cell minus 2.303 log 10 NF. Okay, you also have RT, right? And this is log oxidation by reduction. Okay. This is our original equation, and this is our original equation, and this is at standard conditions. At standard conditions, we usually apply this formula. Okay. So yes, right. If this is natural log, there will not be 2.303. At equilibrium, what we write? At equilibrium, where E cell is going to be 0, Gibbs energy is going to be 0. Right? We write here that E naught cell equals to 0.0591 by N, right, log base 10 Kc. Because this whole is nothing. This thing is oxidation by reduction is nothing but Qc, that is reaction quotient. Okay, very good evening student, very good evening. Yes students, so this is the Nernst equation. Now this E naught you calculate from the equation, right, and this E cell will be, you have to calculate this, and this oxidation and reduction will also be, this is the concentration that we will calculate from the equation, right? Okay. Yes everyone, so we have also calculated this one, right? Okay, now let us okay, now let us go to the question. Okay, let us try to solve this question. Okay, let us try to solve this question. Let us solve this question everyone. Let us solve this question everyone. For a cell involving one electron, everyone here, for a cell involving one electrons. Yes bacha, these are the PYQs only, 2019 PYQ. For a cell involving everyone, for a cell involving one electron, E naught cell is this, okay? One electron means N is equals to 1. E naught cell is given to, the equilibrium constant of the cell is this. Okay, so you have to calculate the equilibrium constant here, that is E naught cell equals to 0.0591 by N log base 10 Kc. Right? E naught cell is given to you, that is 0.59. This is 0.059. 1, N is 1. This is log base 10 Kc. Right? So this is going to be this is going to be 0.59 divided by 0.059. Right, log Kc, right, log Kc, right, this is 1000, this is 100, 0, so this is going to be 10, right, log Kc equals to 10. Which log is equals to 10? Which log is equals to 10 students? Which log is equals to 10? Just apply this, okay? Take the anti-log of this and you will get your answer. Take the anti-log of this and you will get your answer. Answer is going to be 1 into 10 raised to power 10. Right? Okay? Yes students. So, anti-log of 10 is going to be 1 into 10 raised to power 10. Right? How you calculate the anti-log? This is 10. Just apply this. So, 1 into 10 raised. I'll pick a different video for calculating log and anti-log. Because log and anti-log very simple. It's a 10-minute thing. I'll upload it. Okay? I'll definitely upload it. Yes? Next question here is 2006, that is, you have E naught of this and this. The standard EMF of the reaction. You have to calculate the standard EMF of the reaction. Now this is important. Very important question. Everyone in the comment section. Everyone in the comment section. How do you calculate this? How do you calculate this? How do you calculate this? This is Fe to Fe. This means it is actually E1. Let us say E1. This is E2. Right? You have to calculate it for this one. That is to calculate. See, this is having loss of 2 electrons. This is having 1 electron. Right? And here this is Fe3 positive to Fe2 positive. That is again Fe3 positive to Fe2 positive. That is again 1 electron. Right? Okay. So you just have to add it. Okay. What they are saying, see this. So the first one is Fe2 positive to Fe. Right? To Fe. 0 to 2 to 0. That means there is gain of electron here. That means there is gain of electron Fe2 positive plus 2 electrons. That is equals to Fe. Okay, Fe is getting converted to Fe0 by gaining 2 electrons. Here you have Fe3 positive, Fe3 positive, 2 Fe, 2 Fe, 2 positive. This is by student, this is again gain of 1 electron. Now adding these two, what you will get? Adding these two students, multiply this by 2, multiply this by 2, what you will get? Fe2 positive plus 3 Fe plus 2 into Fe plus 2 into Fe3 positive give rise to Fe plus 2 into Fe2 positive. Right? Okay? Then this goes there and it will be Fe positive. Right? Just add these two, multiply this by 2 and add these two equations. You will get the direct equation that they are asking you. Right? Okay? No, yaar. What is wrong here? This is Fe3 positive. This is 1 electron. Multiply this by 2. Right? Okay? What you need to get? You need to get the reverse of this one. You need to get the reverse of this one. I think you need to subtract this. Okay? You need to subtract these two equations. This should be, wait students. Okay, this is plus 2 electrons. This is plus 2. I need to make this equation. Okay, I need to make this equation. So if I subtract, obviously I'll subtract, yeah. If I subtract this one, what I'll get this equation, that is Fe2 positive. Right, this will by subtraction, it will go this side, that is 2 Fe3 positive. And this will go this side, this will be plus, be minus, this will be plus Fe, right? What I am doing wrong here? Oh God, I think I need some break now. I think I am getting confused here. Okay. So this is Fe to Fe2 positive after gaining 2 electrons, Fe3 positive to Fe2 positive. This is gaining 1 electron here. Multiply this by 2. This subtracted Fe2 positive plus Fe3 positive. This is Fe. This is Fe2 positive. This is also Fe3 positive. And this is Fe minus 2 Fe2 positive. So this will be minus this one. So it is going to be Fe here, right? Okay. And this will be plus 2 Fe2 positive, right? And this is going to be, I don't know why I'm feeling like I'm feeling like my head is paining a lot right now. Okay, so this is Fe2 positive. I don't know what I'm doing right now. Okay, so this is Fe2 positive. This should be minus Fe3 positive. Fe minus this. This is Fe. This is Fe2 positive. This is Fe2 positive. Right, this sums out to be Fe3 positive. 3 Fe2 positive, and this is plus 2 Fe3 positive. Right? Okay. So, yes. What do you need to do? If this is your first equation, this is your second equation. That means what we are doing, we are multiplying this part by 2, multiplying this by 2, and if this is your first one and this is your second one, so you are subtracting the second from the first. Okay, we are subtracting this from this one. Okay, that means in that case, if you reverse this, what you will get after reversing this, you will get Fe3 positive plus Fe to 3 Fe3 positive. Okay, this is what this simple maths, no, I'm literally right now, I'm feeling very down right now. I don't know why I'm shivering right now. I think I need some break. That's why I got puzzled in this mathematics. Okay, so guys, understood this? What you're going to do? This is the first part, this is the second part. You just need to multiply this by 2 and then subtract this part from this part. You will get this equation, that is mentioned here. So to calculate the E naught here, what you're going to do? So, see, this is your first equation, this is your second equation. Just multiply this second equation, you will get this. How you get E naught? You get this one, okay? Second minus 1 multiplied by 2. This is what you do, right? Okay? Second into 2 minus 1. This is what I did here, and I get this, okay? And then just subtract it like this, okay? Then just subtract it like this. This is your E naught, this is your E naught, right? Okay? Yes, students? Okay. So this is how you're going to get your E naught here. This is your final thing, right? Okay. So I think I really need to relax now, right? I just need some break for like 5 to 10 minutes. For 5 minutes I need a break. Yeah, I want to take a break now because my body is shivering right now. Maybe I am feeling very feverish. Okay. This change of season in North India, and that is the reason I'm feeling very feverish right now. So give me some time, okay? I'll take something to eat or something. Then we will do the just this minor part is left. We will do that part, okay? Yes. Thank you, bacha. Thank you. So there is break for 5 minutes maybe. I'll see. Okay. Now what's the time? The time is, I'll see you at 4:40. Okay, I'll see you at 4:40. Right, students? Okay? Yes. Thank you, bacha. Thank you. Yes, I am taking the rest. Thank you, bacha. Thank you, thank you, thank you. Okay, so I'll take rest for 10 minutes and then I'll see you. Okay? yes, Bacho. Yes. Am I audible to you? Yeah, actually, I have fever. So that is the reason. I'm feeling very, very, less energetic. That's the reason. But don't worry. Yeah, I just had a rest for 10 minutes and that's it. I'm now a bit relaxed now. I think because of this change of season, no, because of this change of season, I'm feeling very feverish and there is symptoms of cold and cough and all that thing is going on. So that is the reason. But don't worry, I'm fine now and we are going to complete the chapter today itself. Yes? Okay, students. So for today itself, we are going to complete the chapter. Yes, Nishant? Just wait. Yes. Okay. So not much chapter is left. Only few parts are left here. Okay, let us complete that also. So next is spontaneous and non-spontaneous reaction. So what is spontaneous reaction? See, for K equilibrium also, see, if we talk about spontaneous process, that delta G is negative. For non-spontaneous process, delta G is positive, and at equilibrium delta G is 0 and E cell is also equals to 0, right? And also bacha, next is, if this is negative, this negative together forms a positive. If this is negative and this is positive together forms a positive, that means students, if this is negative, if delta G is negative, E cell is going to be positive here. If delta G is positive, E cell is going to be negative here, right? If delta G is 0, E cell is going to be 0. That is at equilibrium, right? Okay, now let us see this. That is 2011 question. If E cell for the given reaction has negative value, right everyone? Consult a doctor. You guys become a doctor first, then I will consult you. Okay. Yeah, actually, my vitamin D and my vitamin B12 is very low right now, and that is the reason I am feeling like very less energetic these days. So I'm taking multivitamins and I have also focused on my diet for that. But that's why you need to become doctor for me, right? Okay, so now next thing is 2011 question. If E cell for a given reaction has negative value, which of the following gives the correct relationship for the values of delta G and K equilibrium? Right, which of the following gives the correct value? If they say E cell is having negative value, that means delta G is having positive value, right? Okay, and K equilibrium will be negative, will be less than 1. So answer is going to be A. Okay, so always remember delta G, the value of delta G is always inversely to, like opposite to, delta G sign is always opposite to E naught and K equilibrium. Okay, delta G sign is always opposite to K equilibrium and E naught cell, right? Okay, next thing students, that is conductance. Now the next thing that we are going to do is conductance. For conductance students, we have different types of conductance. Now what is conductance and what is conductivity? Right, let us understand what is conductance and what is conductivity. Okay, what is conductance and what is conductivity, right? Okay, let us understand that. Firstly, there is conductance. What is conductance, students? What is conductance? Yes, what is conductance? So conductance is nothing but conductance is actually, this is the, like if you talk about resistance, okay, what is resistance? So let us talk about 2-3 things here. What is resistance? Resistance is the restriction of flow of current, right? When we oppose the flow of current, that is resistance. And what is resistivity? Resistivity, this is resistance, and resistivity is this, that is represented by rho. Resistivity, students, is resistivity. Students, resistivity is the resistance per unit volume? Okay, per unit volume, how much resistance you have. Now, what is conductance? That is represented by G. That is conductance. That is conductance. What is conductance? That is the flow of current. That is called the conductance. That is the ease of flow of current is called the conductance. And what is conductivity? That is represented by kappa. That is conductivity. That is conductivity. Conductivity. Now, what is conductivity, students? Conductivity is nothing but this is the if you have this beaker and you see the flow of ions, if we talk about a wire, that is the flow of current. If we talk about a solution, that is the ions. Okay, the ions present, the movement of ions, right? The movement of ions is the conductance in the whole solution. But when we talk about this little part, that is when I talk about this part of the solution, that is 1 unit volume. That is 1 unit volume. That thing is called the conductivity, right? That thing is called the conductivity. Okay, so now let us talk about the formulas here. So electrolytic ionic conductance. Conductance is due to movement of ions in the electrolytic cell. Ionic conductance depend on the nature of the electrolyte, size of the ions, what is the size of the ion that is produced, nature of the solvent and its viscosity, right? Concentration of electrolyte and temperature. See how this is dependent on all these things. See, if I say nature of the electrolyte, that means is the electrolyte strong or weak? Okay, if the electrolyte is strong, the number of ions for strong electrolyte is more than for weak electrolyte. So conductance will be more in the strong electrolyte, right? Then we have size of ions produced. That means student, if I talk about one ion is smaller, so this depends on the size of the naked ion. This depends on the size of the naked ion. Okay, for example, if we talk about lithium and sodium, okay, the size of lithium is smaller as compared to sodium, right? So it will have more conductivity, this will have less conductivity, right? It depends on the size of the naked ion, okay, not the hydrated ion. It is inversely proportional to the size of the hydrated ion, right? Okay, then nature of solvent and its viscosity. More is the viscosity, lesser is the conductivity, right? If there is viscosity, there will not be movement of ions, right? Concentration of the ions of electrolyte, more is the concentration, more. See, very important thing. If you dilute a solution, if there is dilution, how it is dependent? If there is dilution, that means you are adding water to the beaker. If you are adding water to the beaker, what is going to happen here? You are adding water to the beaker. You are adding water to this beaker. Students, you are adding water to this beaker. Now what will happen here? Simple thing is going to happen in this case. Very simple thing. That is the conductance. You are adding the water. The ions, the H positive and OH negative ions are more now. That means the conductance is going to increase here. But the conductivity is going to decrease here. Why so? Because you have a beaker. Now you are adding the water. You are adding the water to this. You are adding water. You are adding water. Right? Now what happened here? You are adding water. This whole solution will have more ions. But this particular unit will have less concentration. This particular unit volume will have less concentration of the electrolyte. That means conductivity is going to decrease and conductance is going to get increased. This is very, very important here. Right? Okay. This is what they are saying. The concentration of the electrolyte. Then is the temperature. More is the temperature, more is the conductivity. Because in that case, kinetic energy increases, velocity increases, kinetic energy increases, conductivity increases, conductance increases. Okay. Now next part is the conductance of the electrolytic solution. Okay, so you just need to remember this formula, that R is equals to rho L by A. That's it. See, 2-3 formulas that you need to remember here. That is R is equals to rho L by A. Where L by A, what is, and also one more thing, that is G into G star is equals to kappa. G into G star is equals to kappa. Now, this G star is the cell constant. G star is equals to cell constant. Cell constant, that is L by A. Okay. G star is equals to cell constant, that is L by A. Okay. G star is equals to cell constant, that is L by A. G into G star is equals to kappa. Kappa is the conductivity. This is the cell constant. This is the conductance. R is the resistance. Rho is the resistivity. L is the length and A is the area. Okay. If you know all these formula, you can derive all the other formulas from these formulas. Okay. You can derive all the other formulas from these formulas. For example, if I write for conductivity, what is the formula for conductivity? R is equals to 1 by kappa into L by A. So kappa is going to be 1 by R into L by A. Right? And this is kappa. 1 by R is nothing but resistance. Opposite of resistance, inverse of resistance is conductance. That is G into what is L by A? That is cell constant. That is G star. Okay. So this is how you derived this equation. Okay, this is how you derived this equation from this one. So you can calculate all the questions from these 3 formulas. If you know these 3 formulas, you will be able to calculate everything based on conductance, resistance and all that. Okay, yes. Now, next we have conductivity, that is kappa, that depends on the nature of the material and temperature, pressure. Then students, you don't need to get into this. Okay. Next we have the formula here. The formula that we are going to use here. See, these are the 2 things, very, very, very important 2 things. That is what is molar conductance and what is equivalent conductance. Okay. Molar conductance is equals to kappa into 1000 divided by molarity. Right? And equivalent conductance is equals to kappa into 1000. That is conductivity into 1000 by normality. Okay? Kappa into 1000 by molarity, kappa into 1000 by normality. Okay? So now, these are the 2 formulas where you will find the concentration, where you find the molar conductance at concentration C. Right? Okay? Next formula, students, here is okay. See this, in this formula, always remember, kappa should be in Simon centimeter square, not in Simon meter square. They should be in Simon centimeter square, not in Simon meter square. Okay, that is important thing, that, kappa should be in Simon per centimeter, not per meter. Okay, if it is in per meter, the answer will be K by molarity, right? But if it is in centimeter, that will be 1000 into kappa divided by molarity, and this is the normality. Already done. Now, next thing is conductivity, and this is a molar conductivity. What is the difference? So as I already told you, what is the difference here? Conductivity always decreases with decrease in concentration. Right? What is the molar conductivity? Conductivity is for 1 unit volume, and molar conductivity is for that 1 mole. Right? So that means on diluting, the molar conductivity is going to get increase. Why? Because we are talking about 1 molar here. We are not changing the concentration here. The concentration, that means 1 molar, that is the same. The concentration is the same. We are not changing the concentration. In that 1 molar, we are adding more water particles. We are adding more H positive, OH negative here. That means more ions. That means more is the conductivity, that is molar conductivity. But if we talk about simple conductivity, that is kappa, that is going to get decrease. Okay, conductivity always decreases with decrease in concentration. That means when you are adding water, that one unit volume will have less number. For example, you have a beaker, and earlier it had A positive, B negative, A positive, B negative. On adding water, here what you have now, A positive, B negative, H positive, OH negative. That means the ions of A positive and B negative are less now in that one volume. Okay, there will be more distance here. There will be more distance on adding the water. On adding the water in one volume, in per unit volume, there will be more distance now, because on adding water, the water molecule are going to add on here. There will be water molecules here. That means the distance is going to get increased. In that particular volume, you will have less ions now. So the conductivity is going to get decreased. So always remember that on dilution, where we have written that, students? Where we have written that? Yes, here. I think, yes, here. Always remember, conductance increases. See, on dilution, when you are diluting this, okay, wait, the conductivity decreases. See, the conductivity decreases, but the molar conductivity, right, that increases. Right, that increases. Or what else increases? Conductance increases. On dilution, only conductivity decreases, all the terms are increasing. Right? When you add on something, when you add water, only conductivity decreases. Conductance, molar conductivity, equivalent conductivity, all the things beta here that are increasing here. Okay? So on adding the water here. Next thing, students, now you have next thing, that is we have already done that. Next is this one, that is Oswald diffusion law. So now what is the effect of conductivity here? See, when we are talking about a strong electrolyte, right? In strong electrolyte, there will be an intercept here, right? There will be intercept at infinite dilution. This is the point of infinite dilution. Right, this is for strong electrolyte, and this is the equation for strong electrolyte. But when we talk about, this is for strong electrolyte, okay? But when we talk about weak electrolyte, it is something like this. It increases gradually and then it goes parallel to the y-axis. Now, for strong electrolyte, we can calculate the infinite dilution. But for weak electrolyte, how do we calculate it for infinite dilution? This is for weak electrolyte like CH3COH, which is like weak electrolyte, a weak acid. For this, how do we calculate it? For that we have Kohlrausch law. Okay? For that we have Kohlrausch law. And what does Kohlrausch law states? Kohlrausch law states that at infinite dilution, weak electrolyte behave as strong electrolyte. When you have infinite dilution, at that point, weak electrolyte is behaving as strong electrolyte. Weak electrolyte is 100% dissociated at infinite dilution. For that, he gave a mathematical concept that they say, if you talk about NaCl, that is, it has its molar conductivity will be equals to molar conductivities of the individual ions multiplied by the stoichiometric coefficient. For example, it releases K2SO4 has 2K positive and 1 SO4 2 negative. So it will go 2 into infinite dilution K positive, 1 into infinite dilution of SO4 2 negative. Right? Okay? Okay, students? For example, we are talking about AXBY. At infinite dilution, it is going to give stoichiometric coefficient multiplied by infinite dilution of A plus stoichiometric coefficient multiplied by infinite dilution of B. Right, and hence we can calculate and hence we can, for example, we have something like CH3CONa. Right, so now we need to calculate the infinite dilution for this one. This will be equals to molar conductivity CH3CO negative plus molar conductivity Na. This is HCl, H positive and Cl. This is Na positive and Cl. Now if you have to calculate the molar conductivity at infinite dilution for CH3COH, that is equals to CH3CO plus H positive. And how you going to define that? How you calculate the H positive? This is your first one, this is second, and this is third. Okay, how do you calculate? Right, this is the first one. So 1 added to 2, 1 plus 2, you will add these two and you will subtract the third one, that is NaCl. So this and this will be cancelled out, this and this will be cancelled out, and hence you will get your final 2 ions here, and hence you will get the molar conductivity at infinite dilution for this CH3 weak electrolyte. So how you calculate how this is the rule applied, that is at infinite dilution the weak electrolyte behave as the strong electrolyte. That is why at infinite dilution CH3CO negative COH is equals to CH3CO plus H positive, the molar conductivity of both the ions. Right, then how to calculate this and this? By using the information that is given to you in the question. Okay, yes students. Next question here is the degree of dissociation. Degree of dissociation means alpha is equals to molar conductivity at concentration C divided by infinite dilution molar conductivity. This you are going to calculate from Kohlrausch law, and this you are going to calculate from M is equals to 1000 into kappa divided by molarity. Right, you calculate these two things. This is from the formula, this is from Kohlrausch law. Then you get the degree of dissociation here. And the dissociation constant is equals to C alpha square. Okay, the C is the concentration of the electrolyte. Okay, yes students. So this is what we have written, that the value of Ka is equals to, you don't need to remember this one. Okay, just simply write it. Ka is equals to C alpha square. Okay, Ka is equals to C alpha square. Right? Okay. So everyone here, wait. Okay. So now let us do the PYQs here. Almost the chapter is ending. 2019 question, following limiting molar conductivities are given as this one. Are you able to see this? This is for H2SO4. This is for H2SO4. This is for K2SO4. And this is for CH3COOK. And you have to calculate it for CH3COH. So this needs CH3CO negative plus K positive. So this is your first one, this is your first one, this is your second one, this is your third one. Here you have 2H positive plus SO4 2 negative. Here you have 2K positive plus SO4 2 negative. And here you have 1K positive and 1 CH3COO negative. Right? So you need to have 1 H positive and 1 CO3 negative for this. Right? Okay. So how do you get it? How do you get it, beta? So you need to have this one. 1 H positive and 1 this one. Right? You cannot see H positive anywhere else. You need to subtract this, right? Okay. So this will be multiplied by half. This will be multiplied by half. Right? So this will be multiplied by half. So, and then you will have 2H, you will have H positive plus half SO42 negative, K positive plus half SO42 negative, and you will have CH3 COO negative plus K positive. Then you just need to, firstly, if this is X, multiply this by 2, multiply this by half, multiply this by half, right? Okay, X and Y are multiplied by half, right? These are multiplied by half. Then you subtract it, then you subtract these two, and this will be minus. Then you subtract X from Y, so then you add it to this, right? Then you add this one. Okay, this is minus, this is minus, this is plus, this is plus, this is plus, this is plus. So this will be cancelled, this will be cancelled, and hence you will have your answer, that is this. So answer is going to be D, that is X minus Y divided by 2 plus Z. Right? Okay, students. So what we did here, we multiplied this by 2, we multiplied these two by half. Have we got this one? H positive half SO4, K positive half this. We have to get this equation, that is CH3 CO negative plus H positive. For that, what I need to do, I need to subtract. I need to see what I did here. If this is X, if this is X, this is Y, this is Z. What I did here, I multiplied X by half, I multiplied Y by half, I multiplied Y by half, Y by half, right? Okay. Then I subtracted half Y and added Z to it. Okay. And this is how I got half of X minus Y plus Z. Yes, students? Okay. Understood this? How you should answer this question? Okay, very simple question, very simple question. Okay, students. Now, let us do the next question, that is an increase in the equivalent conductance. There is an increase in the equivalent conductance of strong electrolyte with dilution is mainly due to. Dilution is mainly due to which thing, everyone? Dilution is mainly due to increase is the equivalent conductance of a strong electrolyte on dilution. Increase in ionic mobility, 100% ionization, increase in both number of ions and ionic mobility, increase in number of ions. So for equivalent conductance, that means for that equivalent, why conductance has increased? Why conductance has increased, everyone? Why so? Why so, student? Because there is increase in the ionic mobility of the ions, right? Because of adding the water, right? There is more mobility of the ions, right? That is why the conductance, molar conductance, equivalent conductance has increased here, right? Now is for electrolytic cell, students. Electrolytic cell, very simple. Okay, how you're going to do electrolytic cell? Very simple. For electrolytic cell, always remember that anode is negative, anode is positive, cathode is negative, cathode is negative here, right? Okay, but oxidation will take place here only and reduction will take place here. Okay, that's it. And anions are going to get attracted to anode side. Anions will be on the anode side and cations will be on the cathode sides. Okay? Yes, this is for electrolytic cell. For example, we are talking about any cell here. For example, I am talking about this cell here. For electrolytic cell, you have just one compartment where you have two electrodes here. This is the cathode, this is the anode. Anode is the positive, cathode is the negative. This is for electrolytic cell, right? So what we are going to do here, at anode, there will be loss of electron, students. At anode, there will be loss of electron. That means copper will get converted to copper to positive, right? And at anode, there will be thinning of, there will be the rod is going to get thin here. Okay, and at cathode, see, what happened here? You had a node here. At a node, there were electrons. At a node, you know, there is loss of electrons. So electrons will be lost here. Okay, so that will jump to the, so that will go to this solution, and there will be, that will go to this solution. Wait. That will go to this solution, right? And there will be electrons here. Okay, so electrons will have motion from this side. Okay, they have motion from anode to cathode. Okay, and this electrode will get thin here, right? Electrons will be from anode to cathode, and this anode side will have thin electron. The electron will get thin by time, and at cathode what you are going to have, this is, at cathode there will be gain of electrons. That means here the copper 2 positive from the solution is going to gain electron, and the rod is going to get thick here, and the rod is going to get thick at electron, and the rod is going to get thick here. This is the rod is going to get thin, the rod is going to get thick here. This is the electrolysis. That means due to the electrical charge, there is reaction that is happening. Okay, yes. Okay, and this is non-spontaneous, right? It's forced by passing a direct current is passed through this. From external source, we have the passage of current. Then there is forced reaction, forced chemical reaction that is occurring here. Here the things are opposite. That means that in this part, you earlier had chemical reaction. That is the reason bulb was glowing. Here there is current. That is why reaction is happening. Okay, yes. Now, next part is already done. Yes, the impure, very important. This is used to purify the metals, right? The impure, they will ask you, which is the impure electron? The impure electrode is the anode one. That is why the impure electrode is getting thin. That means we want it to get thin. We want it to lose the impurities in this anode mud. In this anode mud, it is going to lose the impurities. That is when you dust off your sleeves and your clothes, what you do? You are just dusting off the impurities. So this is what happening here. It is dusting off the impurities, right? By losing electrons and by losing the ions, it is getting thinner, and then those ions are getting electrons and getting converted to the thicker electrode. That is the pure electrode. Okay, and the pure copper is deposited at the cathode. Yes, okay. Now, next is electrolytic cells. So students, see this. If you have aqueous electrolytic, you will have two things here. Okay, you will have two things. Now, this is a molten. This is not aqueous, this is molten. In molten, you do not have water here, right? There are just two ions. Very simple. Okay, you don't need to go into all these. Very simple here. Na positive and you will have Cl negative. Obviously, the positive part is going to get to cathode and the negative part is going to get to anode, right? So there will be formation of Cl2 and sodium, right? This is just they will ask you. Okay, there will be deposit of Na and Cl2. Okay, yes, overall reaction is Na and Cl2. This Cl2 will be at anode and this Na will be at cathode. They will ask you which will be at cathode, which will be at anode. Just simply remember this, that the cation will be at the cathode and the anion will be at the anode. Okay, cation at the cathode, anion at the anode. Now if you have molten, wait. Okay. No other example here? Don't worry. Okay, there will be examples in the questions, I guess. There should be examples in the questions. Just give me a minute, students. Wait, this is the product of electrolysis. Okay, I thought I have added that. Okay. So, see this. This is the product of electrolysis. See this very simple thing, okay? Firstly, we're just going to see what are the things that they can ask you, okay? So, see this. For example, this is the electrode potential, okay? Order of cations to get discharged. So now they are saying, according to the electrode potential, out of this, which ion has the higher charge of getting deposited? Which ion has a higher chance to get deposited? Here C2 positive has the higher chance because this is the maximum electrode potential, right? More is the electrode potential, guys. More is the electrode potential. Or you can say reduction potential. More will be the chance of gaining electron. More is the electrode potential, more is the chance of gaining the electrons. So it is going to gain the electrons here. Okay, so it is going to gain the electrons here. So order of cations to get discharged is, first it will have maximum reduction potential. So it has maximum chance of gaining the electron, maximum chance of getting discharged on the cathode. This is maximum chance of getting discharge on the cathode. More the one ion complete discharge at electrode, the ion will get discharged first, which has maximum electrode potential. Very, very important. Okay, very important. More is the electrode potential, more will be the chance of gaining the electron. Right? Okay. So let us see the product of electrolysis. Firstly, in case of molten NaCl, you have no competition here, right? You just have two ions, that is Na positive and Cl negative, that's it. Na, this will deposit as Na and this will deposit as Cl2 at anode and this will deposit at cathode, right? Very simple, nothing to worry here, right? But if we say in case of aqueous NaCl, see students, in case of aqueous NaCl, you have Na positive, Cl negative, that is from the NaCl. And from aqueous, that is water, you have H positive and OH negative. Now, more is the oxidation potential, more the thing that is having maximum oxidation potential will going to get discharged on the anode. More reduction potential is going to get discharged on the cathode. Right? Okay. So which is having more oxidation, which is having more reduction potential out of this and this? This is having more reduction potential, and from this side, this is having more oxidation potential. Right? So this will be discharged at cathode, this will be discharged at anode, this will be discharged as H2 and this will be discharged as Cl2. And in the solution, you will have NaOH ions. Okay, students? In the solution, you will have NaOH ions here. This is cathode, that is anode. Right? Now, okay? Now, students, next is for aqueous H2SO4. For aqueous H2SO4, students, for aqueous H2SO4, see you have these things. For aqueous H2SO4, you have H positive plus SO4 2 negative, OH negative plus H positive. So in cationic part, at the anode, there will be release of hydrogen only. But at cathode, there will be release of hydrogen only because there is just one cation. But what about anions? We have two anions here, that is SO4 and OH negative. What is going to win here? Out of this, which is going to win here, students? Which is going to win in this? Which one? OH negative is going to win here. OH negative is going to win here because it has more oxidation potential. So this is going to give us O2 and this is going to give us H2 at anode. Okay? Yes? Okay, students? So you will have this reaction. Overall, this reaction will be present here. Okay, students? Now let us, oh my god. Wait. Let us do Faraday's law now. Let us do Faraday's law now. Okay? Yes. Let us do Faraday's law and then few questions. Then there will be just application parts that are left. Ma'am, what type of questions are asked from this concept? You will see that, okay? I'll tell you in the, just these type of questions which will be deposited at cathode, which will be deposited at anode. All these questions. Okay? So yeah, Faraday's first law of electrolysis. There are two laws of electrolysis. Faraday's first law, that is, which says that, so guys, let us do the formula directly, okay? Faraday's first law, it says that weight is equals to ZIT. That equals to weight is equals to this mass. This mass is the mass of metal deposited on that. Okay, so this is the mass that is deposited is equals to ZIT, where Z is the proportionality constant. So now if you want to get into detail of this, I can also tell you the detail of this, how this was formed. Okay, so firstly, the amount of chemical reaction which occurs at any electrode during electrolysis by current is proportional to the quantity of electricity passed through it. That is Q is equals to IT. Yes, that is charge is equals to current into time. This is the first formula. Second, they are saying that if there is n factor 1, there is gain of 1 electron, that means 1 Faraday current is going to be passed from that. Okay, that means 1 Faraday current is going to get passed through that. They're saying the amount of electricity required for oxidation reduction depends on the stoichiometric coefficient. For example, 1 mole of electron is required for reduction of 1 mole of silver ion. Okay, if you have 1 mole of silver ion, 1 mole of electron will be required. That means 1 mole of electron means 1 Faraday will be required. Okay, that means 1 Faraday will be required. 1 mole of electron means 1 Faraday charge. This is what they are saying. Okay, yes. Now next thing is, they are saying that if you have Mg2 positive, you will say that 1 mole of Mg2 positive will require 2 electrons. 2 mole of electrons. That means 2 Faraday will be required here. That means 2 Faraday will be required in this case. Yes, 1 Faraday, okay, 2 mole of electron will have, wait. Okay, don't do this, okay? Don't get into this because you will definitely get confused in this. Okay, you will definitely get confused in this, right? Okay, this is bookish language. Don't get into it. Okay, just remember that 1 mole of Faraday, 1 mole of electron is equals to 1 Faraday charge. Okay, 1 mole of electron is equals to 1 Faraday charge. Next is, see this. Now for Cl2, we know that 2 electrons are required. Okay, 1 Faraday can be converted to anything. Right? 1 mole of Cl2 requires 2 electrons. 1 mole of Cl2, if you have to produce 1 mole of Cl2, you need to lose 2, this Cl need to lose 2 electrons. Right? Okay, so you can say 1 mole of Cl2 requires this much of, that is standard 22.4 liters, that is standard, this much volume is required. That means half mole of, if I want to get 1 electron for 1 Faraday, how much mole will be required? For 1 Faraday, that means half, see, Cl2, 1 mole of Cl2 has 2 electrons, half mole of Cl2 has 1 electron. This 1 electron is called the Faraday. So that means for 1 Faraday, you required half mole of Cl2. And 1 mole of Cl2 has volume, kitna? How much? That is 22.4. Right? And half mole of Cl2 will have how much? That is 11.2. Half mole of Cl2 will have 11.2. Yes, students? How simply you did that? That 1 Cl2 has 2 electrons. 1 Cl2 corresponds to that 2 electrons are lost. For half Cl2, 1 electron will be lost. 1 mole of electron will be lost. 1 mole of electron means 1 Faraday. Right? If there is 1 Faraday, that means 1 Faraday corresponds to half mole of Cl2. And 1 mole of Cl2 has 22.4 liters. That means half mole of Cl2 will have 11.2 liters volume. Okay? Yes? So 1 Faraday of electron discharge this much of Cl2. Okay, this can be directly asked as a question. Okay, next is Faraday's first law of electrolysis. Now students, let us see the Faraday's first law of electrolysis. Very simple. See, you just need to remember this formula that the weight deposit is equals to ZIT. And what is Z? What is Z? What is Z, students? Z is equals to E by 96500. Okay, E is the equivalent mass is equals to 96500. And what is equivalent mass? What is equivalent mass? Everyone, that is equals to molar mass by n factor into Faraday. Okay, so just applying this formula here, we'll have weight is equals to ZIT, that is equals to equivalent by Faraday into IT. You can write it as molar mass into I into T by NF. This is the weight deposited. This is the formula that you are going to use here. Okay, this is the formula that we are going to use here. Yes, okay. This is the molar mass. This is the number of electron lost or gained. I is the current, T is the time, F is the Faraday. Okay, these are the formulas that we are going to use here. Okay. Now we have for second law. Second law says that if you have so many connections that are in series, okay, you're passing the current in series. In that case, they are saying the ratio of equivalent weight by the weight deposited of A electron, equivalent weight of weight deposited of B, equivalent weight of weight deposited of C. All the connections that are in the series, the ratio is going to be equal. Okay, the ratio of, here you have CO2 positive, we can write here, this you have CO2 positive, here you have Ag positive, and here you have Ni2 positive. So they are saying the weight for Cu, copper, for Ag and for nickel is going to be same. The equivalent weight of copper divided by weight deposited of copper equals to equivalent weight of Ag silver divided by weight deposited of Ag. Yes, okay. Yes, students. Yes, students. Okay. Now, students, next thing we have is this is in series. Okay, the equivalent weight of copper is equals to equivalent weight of Ag is equals to equivalent weight of this much, and this is the part that I was mentioning, that equal weight or the ratio is going to be equal. Okay, you can also write weight deposited by equivalent weight. You can also write equivalent weight deposited by weight. Okay, you can also write that. Okay, students. Yes. Now, next part is, okay, just answer this question. Now we have just few questions left, that's it. For 2020 question, the number of Faradays required to produce 20 gram of calcium. The number of Faradays required to produce 20 gram of calcium. The number of Faradays required to produce 20 gram of calcium from molten CaCl2 of atomic mass this. Right. CaCl2 will have Ca2 positive and Cl negative. Right. So this is going to get deposited here. This is going to get deposited at calcium by gaining 2 electrons. That means there will be, it will gain 2 electrons and this will get deposited on the cathode. This is Ca2 positive, this is Cl negative, right? So this is going to gain 2 electrons and get deposited on cathode. This is going to get deposited on cathode, and this is going to get deposited as Cl2 on anode. As Cl2 on anode. Now they are asking you that Ca will be deposited after 2 electrons, after gaining 2 electrons. The number of Faradays. So how many Faradays will be required? The number of moles of electrons that are required. So that means 2 Faradays will be, wait. Number of Faradays required to produce 20. Array, what they are saying? See this. See. They are saying required to produce 20 gram of calcium. 20 gram of calcium from the molten this. What is the molar mass of calcium? That is 40 grams. That means for 1 mole of calcium you need 2 electrons. You need 2 electrons. That means you need 2 Faradays, right? For half mole, that is 20 gram. This is 40 gram. Okay, this is 20 gram. You required 2F by 2, that is 1 Faraday. If they have mentioned that you need 40 gram to produce 40 gram of calcium, in that case we will say 2. If they ask you, you need 80 gram of calcium, what you will do is you will say, you will multiply this by 2, right? Okay. But now they are saying 20 gram. Now 1 mole of calcium has 40 gram of calcium, that is having 2 Faradays. 40 gram of calcium has 2 Faradays, so 20 gram of calcium will have 1 Faraday. Okay? Yes? Okay, next is Neet 2016 question. During the electrolysis, everyone, during the electrolysis of molten sodium chloride, the time required to produce. Everyone here, this is about the first law of Faraday's. So according to the first law of Faraday's, so they are asking that 2016 question, that is the time to produce. See, you have Na positive, this will be get converted to Na by gaining 1 electron. To produce this much of chlorine gas, okay, using a current of 3 amperes, time you need to, see, just apply this formula. That is, weight is equals to molar mass by NF IT. Okay, so here you have the molar mass of chlorine, you have the current passed, you have the current of 3 amperes is passed, molar mass of chlorine, you know, number of electrons that will be lost by chlorine will be 2, N will be 2C, 2 electrons gain, 2 electrons gain, 2 Na. And without Cl, you will have 2 Cl, you will lose 2 electrons, you will get Cl2 here. Right, that means that corresponds to 2 electrons. Right, Faraday, you know, weight, what is the weight? This is the weight. This is the weight. Okay, 0.10 molar of chlorine gas. So, you know the moles, you can easily answer what is the weight. What is the weight? Yes, students. Okay. Shall we move? Just need to apply this formula. Just apply this formula. Okay. You have N is equals to 2. Just apply this formula. Right? Just apply this formula. And this is the number of moles of chlorine gas into this. This is your weight of, this is your weight of, this is your weight of Cl2 deposited. Right? This is your weight of Cl2 deposited. Weight of Cl2 deposited is equals to equivalent weight of Cl2 divided by this. Now students, see, this is the number of moles. This is the number of moles of chlorine gas. This is the molar mass of the Cl1 ion that is produced, right? Divided by number of electrons. Here will be 2. Okay. Number of electrons where we have mentioned, see, this is 71 divided by 2. You can simply write it something like this, okay? This is given little complicated thing here. So we will simplify this. Okay, we will definitely simplify this. See how you're going to simplify this. See, you have weight is equals to m by nf. Just apply this formula. IT, right? Okay. What is weight? Weight is equals to molar mass of chlorine. That is molar mass of chlorine, right? And this is also molar mass of chlorine divided by 2 into Faraday. That is 96500. Current is 3, and you have to calculate the time here. Right? You have to calculate the time here. And this is weight is equals to molar mass into number of moles. Number of moles, how many moles you have? That is 0.10. Right? This will be cancelled and you will have the time here. Time will be 0.10 into 96500 into 2 divided by 3. This is going to be your time. Okay? Yes? You can definitely continue tomorrow because this is the last lecture. This is the last lecture of the syllabus completion, right? And we are just left with few questions here. Neet 2014, the weight of silver displaced by a quantity of electricity. Weight of silver deposited, weight of silver displaced by quantity of electricity which displaces this much of O2 at STP. They have given the volume here. They have given you the volume here. Okay. Weight of silver you have to calculate. That is 2014 question. Weight of silver, that is atomic weight, is given to you, deposited by quantity of electricity which displaces this much of O2. See, this much of O2 will be deposited by how much moles? Okay. So firstly you have to calculate the number of moles. Okay, firstly calculate the number of moles from here. Calculate the number of moles. If you know the number of moles, you can directly calculate. If you know the number of moles of O2, then this is the weight of silver. So they are both are in series. So equivalent weight divided by weight deposited of O2 is equal to equivalent weight of weight deposited of Ag. Okay. So this is the weight deposited of Ag. Equivalent weight of O2, weight deposited of O2, equivalent weight of Ag, weight deposited of Ag, right? Because here they have mentioned two things here. Okay, that means there is application of Faraday's second law. Now, you know the equivalent weight of O2. What is the equivalent weight of O2? Right? Equivalent weight of O2, you know that. Equivalent weight of Ag, you know that. Right? Equivalent weight of Ag, you also know that. Right? Then, weight of O2. Weight of O2 can we write it as number of moles. So this will be weight by molar mass into 22.4 5600. So molar mass of O2 is going to be 32. So that is going to be the weight of O2. Right? Just apply the mole concept here. This will be the weight of O2. So apply the weight of O2 here. You will get the weight of Ag. Okay. Firstly, by applying the mole concept, we find out the weight of O2 here. Then after adding the weight of O2 on this, we'll have the weight of Ag by applying the second law of Faraday's. Okay. So simply, firstly get the weight of O2 from here. Get the weight of O2. Right? Okay. What is the weight of O2? That is given to you. Wait, that is in liters. That was in milliliters, bro. So that will be 22400. Right? Calculate the weight of O2 and put the weight of O2 here. Okay. Calculate the weight of O2. Then put the weight of O2. In this equation, you will get the weight of Ag. Right? Okay. Yes. Next question, students. Next question is, how much charge is required? How much charge is required for the following reductions? For example, from this to this. So from Al3 positive to Al, you will have addition of 3 electrons. That means 3 Faraday. Right? For Cu2 positive, this will be 2 Faraday. For this one, it will have how much electrons? Mn4 positive, this will have plus 7. This MnO4 negative and this is Mn2 positive. This has +7, this has +2. What is the difference here? The difference here is 5 electrons. So charge is going to be 5 Faraday. Right? There is going to be 5 Faraday charge here. This is 5 Faraday, 2 Faraday, 3 Faraday. Right? Okay. Then let us come to the last session. One student was asking how, ma'am, they are going to ask questions from electrolysis. Okay. So electrolysis, this is how they ask you the question. Neet 2022. Right. This is how they ask you the question from electrolysis. On electrolysis, everyone. On electrolysis. On electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at anode will be. Everyone, on electrolysis of dilute sulfuric acid, that is H2SO4, using platinum electrode, the product obtained at anode will be. Right? Dilute sulfuric acid means this will have water also. Right? What is the product? Here you will have H positive, SO42 negative, H positive from water, OH negative from water. Out of this, it is going to liberate H2 gas, add cathode, and this is not going to get discharged on anode, because out of this has more oxidation potential. So this is going to lose the electron and going to give us oxygen at anode. Oxygen at anode. So answer will be oxygen gas at using platinum electrode. Right? Okay. So this is going to give us oxygen gas at anode. Yes? Okay? Yes. Okay. Yes, we have completed the session. One more thing. See, one more thing here. Wait. See, let me find it. Here. Just give me a minute. Just give me a minute. Okay? Just a minute. Okay. So what we can do, I'll just write it here because it will take time. Okay. So students, very important thing here, that out of this you have some theoretical concept of batteries, that is primary battery and secondary battery, out of which questions they will ask, that is conceptual questions. What you need to do, all the batteries that are mentioned in your, stick to your NCERT. For that, you just need to go through the batteries here and learn the reactions of anode and cathode. That is completely a theoretical topic. Okay, nothing to understand here. Okay, completely a theoretical topic, that is anode and cathode. Right? Okay. Yes, students. Right? Okay. Now, as you all know, Shreyas sir is coming. So, here we have the form that you should fill. So that and fill where is your location and everything. Then submit that and register yourself if you want to meet your favorite teachers. Right? And students, next thing is crash course that is available just for rupees. Wait, this is available for 2000, that is online crash course, where you will get so many things, like you will get the mock test, 17 mock test, 20 practice tests you will get doubt sessions on the Vedantu doubt app, you will get summary notes, you will get Tattva PDF, all the things you will get in this PDF, and also the live sessions of all the classes that you will get in this crash course. Yes, students. Next week session, students, we have completed this. Okay, we have completed the class, we have completed the syllabus, okay, now we are going to do practice, and now we are going to do short revision of every chapter. Okay, yes. Okay then, bachcho, bye bye, take care, see you all in the next session. I'll update you on that. Bye bye.